Could be
And
that
if and if
squeaking.
that's the case, I apologize.
Oh, no problem. No problem.
That's all right. You could run your 3D printer.
Complete in your browser. What does that mean?
Okay, we're all here now. People are still filtering in. Anyway, I'm Ken. This is the Propeller Live Forum. Today's January 8th, 2025. Happy New Year. It's 1 p.m. Pacific. Today, one of our customers replied to one of my spam emails, and then, of course, I drew him into the Propeller Live Forum. And that person is Chris Carroll, and he's going to tell us his fish story today, how he uses the Propeller One. So before I welcome you, Chris, I'll cover a few other housekeeping items briefly. Next month, Johnny Mack is going to talk about the product that he has finished with Elite Laser Tag, which is this is a gaming accessory. I'll leave it up to John because John will have a lot to say. So can't steal his thunder anyway. Geez. So next month, hear from John. And then Eric, who is here right now, will be talking in March about what's the status of FlexProp and combining Spin and C, which has been a customer request. So that's today and the next 2 months. And then we have no particular presenters in April. If anybody wants to share anything, just let me know. And the same for May. Recently, new issue, I put out the request for input on a binary downloader tool that could be used for field personnel. So kind of the end user who uses products made by people like all of yourselves when there's a need to put new firmware in. Because some of our customers have trouble with using tools, development tools, they just need a really simple binary downloader. So I posted that on the forums, and not at all to our surprise, I just went today to harvest all the lovely replies and catch up, and I see Maka is already developing something. It's like I wrote it with him in mind, and then he made it better, and then he answered the request with the solution. Pretty awesome, huh?
Wow.
That's good.
No, it's really good. And he does his stuff in JavaScript, so there's a sizable installer, but we really don't care. We want to solve the problem and give everybody an easier solution. So that's pretty awesome. And then Chip's tips on OBEX. This one has been posted. It is customer code deployment in one click. Oh, but the one I wanted to show you today was this one, sharing variables between Spin2 and PASM2. So again, it's on OBEX, and when you go to OBEX on the home page, you will see Chip's tips right here.
I haven't written one yet, but guys have been filling in.
You're doing a great job, Chip. Your ghostwriters are busy at work, and you put up 8 contributions.
Well, we should give credit where it's due. I didn't do any of this yet.
You can keep your job thanks to Michael Mulholland.
Well, I don't know about that.
Anyway, it's cool stuff. Okay, so Chris, want to talk about fish measurement?
Sure, yeah. Thanks for having me on. I have been a diehard fan of the Propeller One for many years for a variety of projects, and so of course thought of it for this fish board. As it turns out, well, let me share my screen here first, try to so you're not just looking at my mug. Let's see, how do I do that? Share. And this guy. It's been a while since I used Zoom, so you might have to guide me a couple times. Anyway, let me just back up just a little bit. I'm a big fan of Propeller, but let me back up and tell you a little bit about the company, why why it exists, and kind of where the chip fits in. So I started the company called Big Fin Scientific. It's been 12 years now. Can't believe I'm saying that, but 12 years ago, actually 13 years ago, we started work for a group in Virginia who needed a fish board. They couldn't, it's a fish measurement device, an electronic fish measurement device. They existed out in the industry. We didn't invent them. But they couldn't find what they wanted. And there was a company who used to make them for these folks in Virginia, the Virginia Institute of Marine Science. There was a company, just a small company, a guy working out of his garage, he used to make them for VIMs, and he went out of business. There were a couple others made by a couple overseas outfits, and they were too expensive. So anyway, they got some grant money put together, and they approached us. Actually, it was my dad and I who were running a little engineering shop in Austin, Texas, and our contract was to make them a single. I think we had to deliver 2 fish boards, and so we did that. We loved the process. We thought it was really fun. We thought there was a big need for them for other offices that are kind of have a mandate to count and measure fish, and I'll kind of describe that in just a minute. And so we bought the rights to it. We started fabricating them, and long story short, we've done 5 generations of the fish board, and some custom stuff, and here we are, 12, 13 years later, still making the fish board, and still based on the Prop 1. But so that's kind of our history, kind of in a nutshell. But let me show you some pictures of kind of, why do people need to count and measure fish? And I'll just kind of pick some pictures out of here to show you. People have apparently, and I didn't know this before we got into this, but NOAA fisheries and state offices have been counting and measuring fish for 60, 70 years, and they do that typically in a manual fashion. Let's see if I can find one that has kind of the manual board. I may not have that, but it would kind of look similar to this. This is a gal in Oregon, and she's out on the docks, and so she's using one of our earlier boards. But anyway, they would have these boards out there, and another person with a clipboard, and they'd call out the fish measurement. And what they're trying to do is ascertain how much biomass of a certain species there is coming in to on commercial docks, and also from anglers, just individual anglers. And then they have other studies that they do, more scientific, where they'll go out and trawl up a whole bunch of fish and try to figure out, okay, what species and how much of them are in various areas, so that they can set quotas for fishing and things like that. So I've kind of gone in a couple of different places there, but essentially that's the purpose behind all of this. Is there are stocking programs, but mainly the thing is to figure out what kind of quotas to set for commercial fishing and individual angler fishing, recreational fishing, they call it. So there are all these state offices that need to do this. They're still doing it. They do, well, most of them are still doing it manually with these boards they typically make themselves. They've got these long forms on clipboards, and they have multiple people kind of shouting out numbers to each other and writing all this stuff down, and then later they take all that data and they put it into a database on a computer, and making a bunch of errors along the way. And so we came along and said, okay, now that we've kind of understood what the Virginia folks wanted, we kind of started to understand, what the needs are. We're going to make an automated process for this, so you can go with one person instead of 2 or 3. Go to a dock, do your survey, do your study, take all your data, go back, and then have it automatically up available, within minutes, so that you can circumvent all the typing in of the numbers and all that kind of thing. So that's what we set out to do. And so after, as I said, many iterations and learning a lot, we finally have what we call our DCS5 system, and that's comprised of, and we were using the Propeller one the entire time. So the first one that we ever had was a big, huge plastic board that looks like this. And this is a gentleman in France. He's on a dock measuring commercial catch. And so so you can see right here, it's all kind of embedded. So we had, all the user interface was all through this alphanumeric display. These are all magnetically actuated keys behind this panel. So he'd use this blue stylus here. Use the blue stylus, and it's got a magnet in it, and you'd poke at these various areas here. We had Hall effect sensors back behind here, and it would pick up the keystrokes, and we had all the menu structure and everything all kind of built into this little alphanumeric display. And there's some precedent for this. We didn't actually, so kind of backing up, we in the course of doing this, this is the form of fishboard that we did for VIMS. This is what we delivered to them. And as it turns out, there was some history behind a design for a fishboard done by some folks in Alaska, NOAA Fisheries Office in Alaska. He had actually devised, using the Propeller, I believe, and this what's called a magnetorestrictive sensor, which is kind of old technology now, but it's essentially senses where a magnet might be along this sensor by pinging a signal down a waveguide and looking at how long it takes for that signal to return off of the magnetic field offered by the stylus. So he had already kind of devised this, and so we, in the course of our research, we contacted him, and long story short, we kind of worked with him a little bit, and then came up with this different formulation of essentially the same guts as what he had come up with. So after this implementation, it turns out it was very large. It was very difficult to make, kind of expensive. People wanted something that was, here's another picture of that same scenario. So they're in this kind of, warehouse. It's right off the docks, warehouse kind of thing. I'm sure it's all refrigerated. They've got all these, fish kind of hanging around in bins from all the different commercial fisheries. So anyway, so this was the big plastic, kind of rotomolded thing was what we delivered to VIMS, and eventually we went through a few different permutations of it, including this kind of metal enclosure, still using the Propeller one, slightly different electronics. We kind of keep improving over time as different components become available, and kind of reacting to what the marketplace really wants. And then finally we have what we call our DCS5. So this is going to a big row of them. They're going to be shipped out. Let me get you kind of a more close-up picture. We do 3D print them, and that's kind of why you hear that 3D printer behind me. This is the enclosure for it. This is that sensor that I mentioned. It's running down the middle, and that gets connected to our control box, which has the Propeller inside. So it's a much more modular system now. It's got a kind of a snap-in battery instead of kind of everything all enclosed. And the major departure between this original one and what we're doing now is that we've developed an Android application that goes along with it. So the Propeller does everything kind of at the physical level where it's driving the sensor, it's talking through the Bluetooth module, it's monitoring the battery charging, the fuel gauge. It's writing and retrieving things off of EEPROM for calibration data and things that we have to store for the fish board. So it's doing all that kind of thing, but then it's relaying the measurements that people take on it to an Android application that we developed. And so there's a Bluetooth link between these two. So here's a scenario where, this is at a trade show. So we got a fake fish here, and so the idea is that you'd use your magnetic stylus to measure the fish, but then also use the board to enter other data about that fish. So it's not just the length, but the species, the sex of the fish, some kind of size code, what kind of defects it might have. People gather a wide variety of different types of data, but these decals that we put on the top here are kind of mapped to different functions within the Android application. So people use these as shortcut keys. So here we have the control box. There are some. Let's see if I can kind of zoom in here, but there are some waterproof connectors that will connect the control box to that sensor that that was in the other picture that runs down the middle and provides the magnetic sensing. But that's pretty much all the board is it has the the Bluetooth. It's got kind of LED feedback for the user. It's got the battery charging, the fuel gauge, memory and storage on there, drives the sensor, and then all the kind of heavy lifting of thousands of records being stored and kind of real-time data being generated as the user goes is all done on the Android side. So we do include, we decided to kind of spend a little bit extra money and do the full color LEDs, and we're glad we did. It's not just for fun and having kind of a pretty ring, but it is important for the folks out there on docks and out on boats. They have to be able to see when they're recording and what's happening with the board in full sunlight, and so that kind of feedback is really important. So it's turned out to be a great thing. We have another version of it the DCS5 box is much larger, so it's kind of akin to that old fish board. It's much larger. It's got the keys available there. It does have a little pit tag or RFID reader embedded, so that's kind of a new thing for this larger box. And the Propeller has to deal with that too. And it's done a great job. It's just been, essentially anything we can throw at it, it does, including the accuracy of and probably the most difficult thing that it has to do is just in the interpretation of the length sensor, because that is something where you're sending a ping down the waveguide, you're waiting for a certain amount of time for that to come back, and you're counting the number of you have to estimate that time. So you're counting the number of cycles. It has to be in real time. You can't have things interrupting it, skewing your data, and so it does a great job of that. We have to have millimeter accuracy, and so we're able to achieve that with the Propeller. So here's a picture of the original. So this was kind of one of the very first. So you can see it's pretty huge. This rotomolded enclosure that you could like surf on it. It was so buoyant. So that was kind of fun. Let me also show you a couple of videos of people using it, because it's I'm so used to how this thing works and how people use it, I kind of fly around a little bit, and sometimes I get ahead of, people stop me and say, well, wait, how does it really work? Like, how do people actually use this thing? So let me show you a couple examples of that. This is kind of a fun application right here. This is horseshoe crab. And so people use it for all sorts of things, crustaceans and fish. So these folks are out on a dock, I believe. And they're weighing them on that Morel scale. And then they're sticking it on the length board. And then they've got a little shortcut key for the sex. So they're recording all that too. So that's what he's doing.
They're pretty fast.
Yeah. And this isn't the fastest. There are some folks who go really fast. So there's a video on my website. It goes a little bit quickly, so I'm probably gonna have to kind of keep pausing because it's really kind of meant to just, it's kind of more of an attention grabber. But so this is one of the folks at VIMS. He is part of the juvenile fish program there in Chesapeake Bay. And so so what they do is they'll go around on their research vessels and they'll trawl up a whole bunch of fish. Unfortunately, most of them die, but they'll take them on board. They'll sort them, take out all the juvenile fish, and try to get as many of the adult fish back in the water as they can, and then they'll stack them up and they'll measure them, and they're trying to get growth rates and biomass of the juvenile fish for various studies. And so he's here with one of the original ones, and you can see how he just kind of like, once he has them stacked up, he can do one every couple seconds. These are some folks in a place called the Trout Lodge. I think they're in Idaho. So they're doing, they do a lot of tagging. So so some people over here are sorting and tagging the fish. They get anesthetized and kind of in this holding tank, and then he grabs them, weighs them, puts them on the board, measures them, and then there's a couple other things he enters into the software. This is a gal on the dock. That's the same French outfit out on those docks that I showed you already.
What kind of fish is that?
I have no idea. And that's kind of a funny thing is I really don't know much about fish. And I keep thinking I'll learn, but because I go to a lot of these meetings. This is a guy in Italy. They got a trout farm over there, so they're doing, it's kind of more of a hatchery or a fishery kind of application, but they're also tagging. So they'll tag the fish with these little glass bead RFID things, and then they're going to measure them. Then they'll go around to different tanks, periodically and see what the growth rates are, and they measure that versus the food input. And they've got all the, their science behind how they raise their fish. But yeah, so as far as fish knowledge goes, I keep thinking I'll learn more going to all these meetings, but it's in one ear and out the other. I'm a mechanical engineer by training, and I've never really been involved with the fisheries world before BigFin. So that was kind of a couple examples. A still picture of some folks in France, doing the same thing. They're out on a research vessel, pulling in a whole bunch. They do a wide variety of studies throughout the year. So they might be doing this type of fish right now, and then out next month doing something else in different areas. They have different ways of doing it in terms of where they might catch the fish and how they do it. So maybe I'll just pause and see if there are any questions about what the system's all about, and then maybe I can just show you a little bit about the implementation of the Propeller in the in the fish for, because I know, you know, y'all are interested in the implementation more than maybe how many fish are counted.
I have a question.
Sure.
This thing that measures the length of the fish that involves a waveguide, what is like the propagation time down and back that you have to measure?
Boy, it's been a long time since I looked at that. I'm gonna have to go back and look. Um, so yeah, I'd have to go back and look at, but it's, you know, it's on the order of, you know, boy, I'd hate to misspeak
It doesn't matter,
in this
ballpark.
forum, but it's, you know, it's not hundreds of you know, it's not tens of milliseconds. It's less than that. So it's I believe it's in hundreds of microseconds.
So the waveguide, is it an electromagnetic thing or is it an acoustic thing? Or
Uh,
how does it work?
they call it magneto-restrictive, and it's essentially just a I don't, you know, I can direct you
Well, I
to,
can look it up, magneto restrictive. Is it like a coil design on a circuit board or something?
well, they do have a little circuit board there to send the ping, and then to amplify the signal when it comes back. I do know that. Other than that, I don't really know the intricacies of the, you know, inner workings. We'll just essentially buy the sensor, and we'll do kind of a secondary waterproofing for our purposes, and then just interface to it. And they have a variety of them. This is what used to be MTS sensors, which is now Tempesonics. So if you want to look that up.
Well, did you say magneto restrictive or resistive?
I thought it was magneto restrictive, but maybe I got that confused over the years. I
What is
always thought it was magneto
magneto-restrictive?
restrictive.
So it's the ability of a material to undergo mechanical strain in response to a magnetic field. So is this some kind of like sensor that you have to purchase, and is it expensive?
I do have to purchase it, and it is one of the more expensive parts of the system. So you know, we're a little bit of a system integrator in that we'll go and buy, you know, the sensor, and um, I guess that's about it. Now we do the, you know, the circuit board's kind of custom, but you, am I coming through now? Am I okay? Let me know if I'm breaking up.
Yeah, you are.
I'm back now. Okay.
You are.
So I'm not sure where
My internet's not great either.
okay. Well, maybe Chip, if you can like raise a hand or something if I'm, you know, if you can't hear me, but I think where we left that off is
Okay.
we're a little bit of a traditionally we've been kind of a system integrator where we'll buy the sensor, we'll buy the alphanumeric display, we'll kind of put these various pieces together and just package it. It's gotten more streamlined now, so the only thing really that's not custom, you know, is the sensor. So we will buy those. We buy them from a company called Tempesonics, and they're right here in Cary, as am I, North Carolina, and they've been doing it for many years. So it's not a new technology. It's pretty pat now. You know, they've made some innovations over the years to make it better, but it's definitely not a new technology. So we'll buy those. They are one of the more expensive parts to the system, and so that's kind of more of like, you know, buy, do some processes to it like waterproofing and then resell kind of thing, and bundle it as part of our system.
Right.
So we don't have the expertise to make those sensors in house, if that's what you're wondering.
Yeah, I'm looking at them. Yeah, they are called magnetostrictive. Let's see, magnetostrictive. So yeah, these are like mechanical and electronic assemblies that don't look trivial. So there's some some engineering behind this. My reason I'm asking is I'm just wondering if there's something that we could like maybe make an object for, and then you could the customer would make something, you know, not too expensive to realize the whole system, like maybe a long circuit board with some traces. But it looks like there's some kind of like mechanical flexure occurring under the magnetic field, and then their sensors somehow resolve that and then return to you some kind of pulse length or something.
Yeah, exactly. So they have a few different flavors of those sensors. So, you know, they have ones that will reply in like, you know, a CAN protocol and, you know, a couple other things. The difficult, so you mentioned, you know, some kind of alternative method for doing it, I think is what you said.
Yeah.
So in the past, people have tried to, you know, approach this in a couple different ways. You know, a long time ago, actually, even some of the fish boards made by the Norwegian group, the ones that I mentioned that are really expensive, and so, you know, NOAA didn't really want to pursue them. They do use like a long array of Hall effect sensors to interpret where a magnet might reside. The same thing with the gentleman I mentioned who was kind of running his company out of the garage and stopped doing it in the mid 80s or mid 90s. He took the same approach. As you can imagine, that turns out to be very expensive. And of course, you can do it. You can mux all those signals and do all that stuff. But just the component count and everything was very expensive. The other aspect to it is there's a high, you know, the requirement for accuracy is pretty stringent in that.
Right. They want millimeter.
Yeah, they want millimeter accuracy, which means your resolution needs to be, you know, a tenth of that or something close to that. So maybe a fifth of that. So, you know, so the accuracy is something that you know, that does come into play.
Yeah. You could probably know the accuracy by making like a histogram of a whole bunch of measurements and make sure there aren't periodic peaks, which would indicate something like a bunch of distributed Hall effect sensors,
Right.
you know, that aren't resolving every interstitial space right.
Right. So we found this to be, and the other thing about it is, you know, you have this thing out in kind of extreme temperatures, and it does get abused quite a bit. So the beauty of the Temposonics sensor is that if you package it correctly, it's very abuse resistant. And so that has been great. And it's easy to seal because it's a long, you know, it's a small volume. It's long, but it's a small volume overall. And so, you know, early on with a lot of our earlier attempts at the fish board was to kind of, you know, take the guts out of the sensor and kind of repackage it in our enclosure, our waterproof enclosure. And that's the approach we took with this model here. This is actually an aluminum enclosure with end caps here that are kind of sealed off on both ends. And we put everything inside, all our electronics, batteries, the sensor, and it was a kind of a tight packaging job. But we did that. It turns out it's difficult over the years to keep that sealed. And so we ended up with this approach that I mentioned where everything's much more modular. We just depend on the you know, the aluminum channel of the Temposonics sensor for that area of waterproofing, and then we just waterproof our small box, you know, the control box here, you know, one of the two flavors, and then we connect with some waterproof cables, and that has turned out to be a lot better over, you know, years. So now we have some of these in the field for 3-4 years, and we don't have, you know, nearly the problems that we did with the aluminum extrusion ones.
Yeah, that's nice how you've separated the problems.
Yeah, yeah.
So that's neat. So you use Bluetooth. Oh, sorry.
I was going to ask. You said early on that the data from the control box just comes out and goes into a database automatically. Can you say more about that?
Sure. So the control box, interprets the. This is a picture of one flavor of the styli. It has a magnet in there, and so this is just showing. You can use this little stylus for the tablet, which is running the Android application, and then the magnet for the board. But to answer your question, the control box will interpret the location of the magnetic stylus when you place it down. It will relay that as a length, so it's a simple alphanumeric message over, nothing. It's just a old school kind of classic Bluetooth connection. So no encryption, no, nothing. It's not even BLE. It's just the old standard. And as a kind of peripheral, I think it's a simple peripheral device protocol. So it's just open alphanumeric. It has a certain messaging. The Android application will interpret that message, and it'll do it in different contexts too. I mean, this has nothing to do with the propeller, but just on the aside, the Android application will interpret that position of the magnetic stylus just depending on what the user is the intent of the user. So what are the users trying to do? Whether they're trying to put in a shortcut code or whether they're trying to take a measurement. There's a way to kind of communicate that with the Android app, so the app knows what they're doing, and then it can react accordingly. But essentially, it's just sending a length over the Bluetooth channel to the Android app.
So it's really kind of operating just like about a serial port, where you don't have any kind of protocol stack or anything.
No, it's just a message, just an alphanumeric message. Serial
Where
protocol.
does it get stored? How does it get stored? Where does it get stored?
It all gets stored on the Android tablet. So the only things that get stored on the fishboard are things like calibration data, some information about the firmware when it was last updated. What are some other things? Oh, there are different modes that the fishboard can be in for different applications. So I mentioned this Android application. That's one application that can operate with the fishboard. We decided to make the fishboard kind of an open platform, so you can make your own application and interface to it if you like. And so there's, on the Big Fin website, you'll see this protocol, which is just, what the messages are and what it means for your own application development. So if you wanted to connect to the fishboard over USB or Bluetooth with your own application, and some people have done this, then you can, that's how you can interpret the messages. So it does have different modes, just because for historical reasons, it had to have different modes for different applications that we've kind of helped people do over the years. And so that's stored there. We used to pay attention to the temp and humidity for various reasons. We don't really do that too much anymore, but there is a temp and humidity device on the circuit board that the Propeller pings. So it has that kind of stuff, just kind of like fishboard related data is stored on an EEPROM on the board, but everything else, all the fish data, all that kind of stuff is all stored on the Android app or on the tablet.
How many man weeks do you think you have invested in that application that runs on the tablet?
That is really hard to say. That's a good question. It's really hard to say because it has evolved so far over the years. It's we started it back in 2015, I think, 2016, and it just keeps our approach has been, we find it's such a small marketplace. There are really, it's a tiny marketplace. And so we get to know all the players kind of, pretty well, all the customers. And we will just work. So essentially they'll come to us and say, hey, we need these new features. We love your system, works really well, but we need these new features. Can you do it? And so it's just evolved over the years,
Yeah.
and it's really hard to say how many hours. But I mean, it's a lot. There's a lot of effort in that Android application, not only because you have to build the new features and just keep updating and all that kind of stuff, but you also have to keep it up to date because Android, the platform, Android as a platform just keeps progressing year after year at such a rapid pace that, we ran into problems where we had old libraries and they just weren't supported anymore, and it caused problems. We couldn't do these feature updates or bug fixes because we had to tear out an old library and put a new one in. And
Yeah, Windows used to be like that.
yeah, okay. Well, that's what we're running into. So it's not just the effort to fix bugs and put new features in, but it's also the overhead of the platform moving on you.
Yeah, yeah. It used to be that we spent like Jeff wrote our Propeller tool application. And I think at one point, like it seemed like over half his time was spent dealing with Windows changes, destroying the functionality of our program. And you have to keep going back and fixing things. But I think these days it's not changing so much. At least whatever we write continues to work, and it seems to have leveled out a bit.
Well,
Was it hard to
That's
get
good.
started with writing the Android app? Was it pretty straightforward, or was it like a really steep curve?
Well, I'm not a software developer, so I didn't do it. I had a contractor work with me over several years, and I really lucked out with. It was a couple guys. They were in Ukraine actually, and this was back in 2016, 17, and they were just really good. So I can't speak to the difficulty, but they were pretty proliferous in their, I mean, they were pretty productive. So apparently for them, it wasn't so bad.
Neat. I wonder, do you have any idea like how many lines of source code are in that thing today, or how
Oh
big
yeah,
the
wait,
file is?
it's huge. It's huge. So when I try to get, and it, yeah, I don't know the number, but it's really big. And it shouldn't be that big. I mean, if it was more optimized, it would might be half the size. I don't know.
I see.
and that's a big fish too.
I know those are really, really interesting fish, right?
And it fits on the fish board for being so long.
Yeah, we do have standard sizes, but Temposonics will produce a sensor up to 2 meters, 2.5 meters, I think. Not that we've ever made one that long, but one of the ideas behind the 3D printed approach is that obviously you can just keep stacking these parts together as long as you need, and have a longer board. Then you just need a longer decal. So that was kind of another way to make it more modular. This is a little battery port there, but essentially this is kind of the standard or most common part to building up a board, this B section. So we just keep adding more and more to the assembly.
Neat.
We used to, so this was kind of the one generation back. I found a place that had these, bought these extrusions, and then I had CNC the other side of it with a bunch of features to house the sensor and do everything that we needed to do, put the feet on and all that kind of thing. But it just created a lot of excess plastic, which I didn't like. And it was kind of time consuming. So the 3D printing has really turned out to be great. We're going to, well, actually I already have open source those, so people can just download those and print them off of the website.
Oh, so your customers can kind of lengthen their own
Yeah,
boards if they want to?
Yeah, or repair their board, so they don't have to ship the
Oh,
whole
right.
board back to me. They can pop a section off, print up their own, stick it back on there. So I'm really trying to make it very, as open as I can to so that people, try to decrease their costs, their maintenance costs, their overhead, and just making it an easier system to use.
Neat. When you talk about calibration, do you have to can you move the stylus to what is like 2 points and do an overall calibration, or you just move it to the end point and then do a calibration?
It's the prior one, so we just have it, 2 points, one at 0, one at some other point.
Okay.
So this is the latest. Oh, can you see this? I'm not sure if you can see it.
I see a bunch of like tiles of pictures.
Okay, let me redo my share here.
Your screen aspect ratio is really like wide and not tall, right?
It is, yes, you're right. It is kind of wide.
Okay, I have a joke for you. How does a fish know how much he weighs?
And then he got me.
He
I
has
mean,
his
other than
own,
like,
he has his own scale.
oh, he has his own.
Grover thought
That's
it was
good.
funny.
That's good.
This
Not
is one of the
bad,
more
not
interesting
bad.
projects we've seen. I mean, this is a really good example of like customer-driven need and years of
Yeah.
innovation to keep doing what your customer wants you to do. I mean, you can do this the rest of your life and a few more lives.
Yeah, it's really been great because it's a tiny, like I said, it's a tiny marketplace, but it was just enough to keep us going. It was just enough interest and just enough kind of early adopters from NOAA and some state offices that had a little bit of money, because these were not cheap when we first brought them out. They were like 10, 12K or something. It was like
That's what
they
I
were
was
very
thinking.
they're very expensive to produce, and so they're very expensive, and we only had a few customers, so we had to make them kind of, very expensive. Now we were competing against, the Norway group that was selling them for 25K, and so we're like, wow, this is a bargain, We're
They
we're
have
we're we're, we're, we're giving these guys a bargain. So, and everybody thought that was great too, but then we quickly ran out of, the people who had a whole bunch of money, and we had to innovate and get the costs out. And I think we've done a really good job of that over the years to get all the costs out that we can, and kind of streamline it. And now, and sorry, so the other part of that was that with those early adopters, most people in this industry, in the fisheries kind of world, do not trust electronics. They do not want electronics around. They want to just have, to do the same way they've always done it. And there are a lot of people in there who have been doing it for a long time, and they just didn't want any changes. And they just, so they just wanted the same thing. But the early adopters kind of proved that it could be, done. It did optimize a lot of processes for them. It decreased the amount of, reporting time from when they were on the boat to when they could report their data. Decreased the manpower, it streamlined a lot of things and saved a lot of cost. And some people saw that. The next generation of people or next group, I should say, of people kind of adopted it, and they proved, so it's kind of grown over the years, and it takes a lot of time with, as you can imagine, like there's government offices, so like USGS, NOAA, Department of Fish and Wildlife, Parks and Rec, all those places that are doing stocking programs and whatever else, and all the research and everything else they're doing, they are slow to adopt because they've got a whole bunch of research data that they are, that they have to compare their new data to. They don't want any kind of changes to that. They don't want anything that can cause error. And on top of that, it takes them a lot of time to purchase new equipment, train new people, get things kind of going. So it takes a lot of time. We finally, I'm always amazed at how that I've been doing this for like 12 or 14 years till I think about 12 or 13 years till I think about how long it takes for these government offices to adopt something. And so they finally we're finally at this point, I think now where, they're starting to kind of adopt, the system, and we're starting to get into marine commissions, fisheries commissions, and things like that, where they, they're starting to see the value um, and start to adopt it. I mean, it's still tiny. It's still, it's never going to be a large marketplace, but at least, we're out of the onesie twosie, to the really rich NOAA offices, to, more, I'll call it mainstream, state offices.
And this is
Um,
how the propeller is used in all these kind of low volume contraptions. They're very common. I mean, you don't find it in Amazon hardware,
sure.
stuff made in Asia, but it's all these inventors doing unique niche based products.
Yeah. And I
Perfect.
will
Yeah.
say, as just to round that out, because you were kind of mentioning, kind of the progression or whatever, or asking about that. Another thing that's really helped us is the parallax community. So, I bet you I've talked to one or two people here, though I apologize if I don't remember your name. It's been, but I have gone on the forums. I've asked for help. Johnny Mack has actually written something for me, or helped me. And he did write something, and several other people have been really fantastic in helping with the kind of object code behind all this. And so that's another kind of aspect to this, just the community helping out with the development.
Very cool.
That's
Well,
good.
unless we have more questions for Chris,
I do have one other thing,
please share.
but I mean after questions.
Okay.
I have one question about the 3D case. What's the life of that? Do you, once it's out there in the salt water and all that sort of stuff, and being
Yeah.
bashed
Yeah, are those
with
kind of
fish on a daily
parts?
basis?
Yeah.
Yeah, go ahead.
Yeah, good question. Because the 3D printing materials run the gambit, right? From just kind of commodity stuff that's pretty fragile, but gives you really good detail for just prototypes and stuff like that too. Nowadays, they have some materials that are really great for outdoor environments. So the material that we use is called a PETG. But it's also carbon fiber infused, which makes it really nice and stiff and really strong. The PETG does great in resisting UV. It's the salt water doesn't affect it. It's really durable, especially with the right geometry, and so it's been really fantastic. If you'd asked me 5-6 years ago whether that's really possible, I don't think it really would have been too feasible, or it would have been a lot more expensive maybe, but the printers and the materials have come such a long way in the past 5 years that it's really kind of enabled that. So they last for a really long time if you don't drop them or bash them or whatever. Start defending yourself from sharks with them or whatever. So yeah, they're great with that particular. The PETG is great with UV. There are a couple other materials as well, but that's what we use.
And it sounds like they're not particularly brittle then, so you've got to really drop them to smash them or crack them.
You really do, yeah. With this material and the carbon fiber, they're pretty tough. You can definitely stand on them, throw them around, throw them in the back of a truck. They get thrown around in docks a lot. Fall off containers, all that stuff. So
and the wall thickness, the print thickness is from the photo, it looks quite thick. What would you say that is in sort of millimeters? Is that sort of 5 millimeters?
Let's see. No, it's not 5 millimeters. not 5 millimeters. It might be like on the order of like 3.5, 4, something like that. Um, and they are hollow. They do have hollow spots in between, like in between the walls. There's what they call infill, but there's like either a zigzag or some kind of grid pattern or something between the solid walls. So this isn't a completely solid piece, and you really don't need that. So it's a good thing to fill
Does
it up
that mean
with.
it's buoyant?
Well, it's buoyant to a certain degree, but with everything else kind of bolted to the board, I doubt it would actually float, if that's kind of where you're going. But yes, it does have some buoyancy. They typically, by themselves, you just have, the part by itself. I wish I had a better picture here handy. But yeah, they'll float if you just put them in the water by themselves.
So then the last question, I guess, what's the print time roughly for one section?
It does take a long time. So each one is about a day.
Wow, each section or each entire board?
Each section is about well, it's not a day. It's about 16 hours.
And then you've got how many sections to a sort of average board? I know they vary in length.
Yeah, so for a 1 meter board, and of course, we got different sections and they take different times, but just on average, we got about 10 or 11 sections.
Wow.
Is that right? Nine. So yeah, each one will take 9 days or so, 9 or
So
10 days.
does that mean you've got 10 3D printer machines on the go then?
Exactly. So we do have a farm that we
Yeah.
run, and so we're always producing. And trying to create some kind of stock a little bit.
Yeah.
But yeah, we keep them running pretty
It's a board a
constantly.
day sort of thing.
And then you have these long decals that go over the whole thing.
Yes. Yeah, so those are some like really tough kind of, I don't know. We
Vinyl
found
wrap
we
of some
found a
sort.
company. Yeah, we found a company who prints those, and they have like this really tough outer covering to them. And they do really well. They do last unless the user is going after the horseshoe crab, that you saw earlier, or some
Oh,
really
yeah.
spiny rockfish, or things like that. They will last for 2 or 3 seasons, and they're fairly inexpensive to reprint, and then you can just customers can apply them to the board. They don't need to send their board back to us. They're really not that difficult to put on.
They need to have some kind of sealing over the printing though, right, to hold up?
Yeah, so you can't really see it, but the construction of the decal is such that the printing is on the bottom, and then you've
Right.
got, yeah, which I think is like, unfortunately, I think it's vinyl. I wish we could find a more ecologically sound, plastic. But anyway, there's a vinyl. They have some other kind of, some other interface material, and then they have this really thick thing on top, which is clear, has a texture to it, and that's the kind of protective layer that goes on top.
And the adhesive is so good that it can wrap around without coming undone, right?
That's right. Yep. Yeah. So this is a example of the edge of the decal on the old CNC cut extrusion.
Yeah, so it looks really seamless when it all comes together.
Yeah, I've always been really I've been happy with this kind of DCS5 arrangement. Of course, what we call our DFS2 had the same type of decal running down the center, and it may have even been arguably more finished looking just because it had end caps, and
Yeah.
everything was inside. So
That's interesting that you're taking like 3D printed stuff that takes a while to make, but then making lots of it in parallel and actually shipping it as the product.
yeah, yeah. Essentially, you just have to, if you've got 10 days in a product, then you just got to scale up on the infrastructure to be able to produce in any kind of decent numbers. So, now, fortunately, again, if this was 5, 6 years ago, we wouldn't be able to do it because the printer cost back then was too expensive. These days, printers have come down in cost to such a degree that we can do that.
Yeah.
Here's an example of 3D printed, what we call a nose stop. That's again for the extruded board. So that's how we used it back then. And now we're just building the entire boards with the stuff. Here's a picture of the circuit board. Here's the propeller. Got some power supply stuff over here. Here's your crystal you always have with the propeller. Bluetooth device. There's a little temp and humidity sensor over here. Anyway.
So is that connector on the end what goes out to that Tempasonic sensor?
It is, yeah. So it's a
just 2 wires.
So it's an 8-pin connector.
Oh, that thing there. Okay.
Yeah. Of which we use 6.
Okay.
And we do have a USB, so you can talk to it over USB instead of Bluetooth if you want.
Very nice. Ken incidentally said he got dropped off the internet, so.
Oh, okay.
Yeah, I came back on my phone.
Oh, okay. And here's the CAD, corresponding CAD for that.
Chris, I had a quick question. What's the longest fish you can measure with this?
So most people buy a 1 meter board, and so I guess the quick answer would be the 1 meter. But some people have implemented a different nose stop, which is movable, and so they ignore the first 30 centimeters of a fish and measure 1.3 meters long on a 1 meter board.
Right.
But we can build a 2 meter board if people want us to. We just I think the longest we've done so far is a 1.2 meter.
I wonder if it's possible to do something like when the fish is on the scale, have an overhead camera and have some kind of machine learning thing look at the fish and kind of know the scale of the scale plate, and then, well, some things are going to drape over the scale, right? That's.
Yeah, there has been some work done that way. There are, of course, a bunch of difficulties in that, in terms of lighting quality and accuracy and
Right.
that kind of thing.
The fish can be twisted or folding and.
Right.
Right.
But certainly there has been some work done that way. Here's just really quick. This is I didn't find this earlier, but this is kind of overview CAD of what it looks like, all the pieces together. Yeah.
With that Tempasonic sensor, yeah, that
Right.
sensor looks really expensive.
It is quite expensive. Yeah, they can be, $600-700.
Yeah.
Depending on the length.
I wonder if they, that maybe what they're doing is sending some kind of little transverse wave down that, and then where the magnetic field is, it pulls it up and then causes an early reflection or something.
There are a bunch of papers on the Tempasonics website. So if you're interested in the technology, they do a really good job of explaining it there.
Yeah.
So I'd take a look at that. Shoot, I just saw the time, and I know somebody's waiting for me to stop gabbing, and so they can do something. I just had one other thing I would like to raise, and that is we are going to be doing some new kind of feature adds to the hardware this coming for 2025, and I would love to, for any of you smart people who actually know how to program on the Propeller. I'm kind of a neophyte. I just get lots of help. If anybody is interested in collaborating with me, me hiring them to do some software work, I would love to hear from that person. As we go into 2025, we're going to be doing adding new devices for some weight measurement and doing some other things. So I'd love to get some help and as a contract kind of thing.
You want to post your contact information like in the chat?
Sure. Yeah, absolutely.
Just like an email address or something.
Or people can contact me if you're watching the video. Just contact Ken, and I can connect you with Chris too.
Okay.
Yeah, okay, here we go. I found the right. I will do that. So yeah, I'll go offline because I know I've talked enough. So, but I'll go offline and I'll do that in the chat here.
Well, Chris, this is awesome.
Yeah.
The questions from the community are kind of funny and different too. So it was good to hear about 3D printing and how you put this whole thing together and just how your business evolved.
Yeah, it's great. I really appreciate the opportunity to talk, and also, to say thanks because the Parallax community has really helped out with everything we've been doing for over 10 years. So so my chance to say thank you. But yeah, thanks for having me on.
Thanks a lot for coming.
Yeah, and have fun with the robots and your kids too.
Yeah, I'll report back. I have not had a chance to get that thing going, but I will report back.
Okay, awesome.
Yeah,
all right,
really
well, thank you all.
impressive.
Thank you all. I'm going to sign off, but
Okay.
I'll write in the chat.
Cool. All right, that was pretty cool. So let's see, Chip. Before you talk about preprocessors,
Let's have Ada.
Yeah, Ada wanted to share something, and she's been patiently waiting and not feeling well. So let her rip. And I've had to put myself on mute because I'm in my car and I've made you host.
Okay.
Thanks.
Welcome. Is the sound working today?
Sounds good.
Yeah.
The
Okay.
previous share stopped.
It makes out weird because I'm like very sick, lots of coughing, low energy all day long.
Oh, sorry to hear.
Anyways, we have entered the age of screen sharing doesn't work. You cannot start screen share while other participant is sharing.
Yeah, let me see here. How do I?
You'll have to steal it back from Chris.
Okay, let me find. Oh, here it is, Chris Carroll. Okay. Let's see. Well, I don't see how to stop. Chris, if you're there.
Chip, if you take it over at least, then you could stop sharing and then Ada can share.
Sorry, hold on. Let me see if I can unshare here.
Looks like you're dealing with a fish.
I can do
don't
it.
know how to okay.
Here, let me do this. Okay, and then share, and then I will stop sharing. And now I've gotten it away. So now anyone else can share. So Ada, go ahead.
Anyways, we have entered the age of teapot. Isn't it magnificent?
That really is.
Also, it spins.
Whoa,
Wow,
that
that's cool.
Yeah, this is the latest outgrowth of like 3D rendering thing. This is just the exact same thing that's on the forum already. Haven't really had time to advance to the next step.
That's amazing. It looks like you got the frame rate up pretty high.
No, not at all. It's at like 20 or something.
That's pretty good. But you think
No, 20 is not good.
Well, you were saying you could get it to 60, you think?
Yeah, that would be good.
And there are like 1,700 polygons in this?
No, it's like 2,000 something. You can see them all
Wow.
if I set it to this mode.
That's cool. Wow. I've always thought this kind of thing would be great for like shapes that are forming, like that are resulting from measurements that are live, that you could then, show and then scroll in some fashion. It could open all kinds of interesting doors.
Yeah, currently it only does like static shapes. There's nothing particularly preventing you from making it shape up dynamically, but the problem there is that you have to like turn it into a triangle mesh.
Right. That it's amazing that there's really no indication of how low the resolution is until you see the aliasing when they're high contrast.
You can kind of see it on the edges of the thing. It's kind of
Yes.
harder because it's against like a completely black background. It's a very high detail shape.
Yeah.
But you kind of see some weird gaps in the shape when it's like this.
Well, we talked about this one time, but it's not really possible to anti-alias the edges. But if you could, then you could actually hide the coarseness of the resolution better.
Well, the easiest way is to just draw it at a higher resolution.
Right. Well, yeah, that takes a lot more processing though, right?
Yeah, there's some way that you can, in theory, write an extra value for each pixel that tells it if it's on an edge and then later blur those edges over. But that doesn't entirely work as well and also needs more memory. And you probably couldn't implement it quickly on the P2.
Yeah. Are you using 565 or 16?
Yeah, this is the 16-bit mode.
It's amazing. I think if it were like 24-bit, it would be it would look a little bit
Not that much.
not that much.
Because it's already using dithering. The real reason you see color banding is because the texture only has 256 colors.
Oh, okay.
There's a reason for that because it's easier to calculate. Well, for one, it's smaller, but it's also easier to calculate the address if it's only 1 byte.
Yeah. That's so amazing. So how many cogs are involved in this?
The actual triangle drawing that's handled by 4 cogs. That's the whole thing that's really done in big air quotes. But all the geometry processing is currently just done with, I say spin code, but half of it is like awful inline assembly.
Okay.
And it's just in one cog because it's, and this is what's taking most of the time. Like if I turn the texture back on, for this particular view here, it's taking only 4,190 microseconds to draw, but it's taking 42,400 something microseconds total. So the actual drawing is like 10% of the speed.
Whoa, so the rest is the computation of all the, and it looks like you have lighting here too.
It's actually fake lighting. It's just
enough
using
for
an
me.
environment texture.
Yeah, I was going to say the lighting in this is what really makes it stand out. It's a high quality image.
It's very, very cheap trick. It's just we have, let's see if I can share this application. Where is it? Oh, there we go, graphic scale. This is just the texture.
Oh, that was mapped over the entire surface of the pot?
Yes, it's just a sphere.
Oh,
just
I see what you're, so you've got like 4 lighting sources, 4 bar lighting sources there.
Yes, yes. It's just baked into the texture, so this is like a cheap trick to make a shiny object. This has been known and used since like the 90s.
Well,
and it continues to be used. Like this exact technique is actually built into something like Blender.
It's sufficient.
Yeah, it's kind of, the trick here is that with this picture of a sphere, if you think about the normal vector of the surface, as it is transformed into the view space, right? If it's pointing directly at you, it's 0, 0, and then z is -1 or +1, depending on how the coordinate system works. But x and y are 0. So if the we get something that has like a grid. No. Lovely. Ah, there we go. So if it's like the normal is in the middle, we sample the middle of the texture, which is what reflects what's essentially behind the viewer, right? Like what's in the center of the reflective sphere is what's behind you. Whereas what's on the edges of the sphere is what's behind the sphere, right?
Right.
So this essentially inside the texture does the conversion from a normal vector to a reflection vector, which is twice the normal vector in sort of rotation, not twice in scalar value. You get it, right? Like if the normal vector is pointing sideways,
Yeah.
like here, then the reflection vector of this part of the sphere is pointing backwards.
Right.
And of course, there's some sort of Fresnel effect. I actually rendered this in Blender as well. So you can use
Interesting.
you can make it any color, any sort of roughness.
But even wrapping this onto the spout and the handle, I didn't really get the feeling that the lighting was off at all. It still looked real to me, even though it was probably opposite of what it should have been in some cases, right?
Not really. It's correct for the direction, but it doesn't handle the fact that the handle would in some cases be occluded by the pot itself. And of course, it doesn't reflect itself either. However, and this is not that visible with this sort of setting and texture, I have added a little trick, which becomes more visible if I change the shade color. Let's change the shade color. Where's that? Oh, where's the shade color? There we go. Let's set it to white instead of black. Now it's a white shade color, and you can see that all the parts that are sort of self-occluding, they turn white.
Oh, interesting.
And previously they would have turned black, but you barely
Well, yeah,
even
now it
noticed
looks
that.
kind of like a negative now.
Yeah, exactly. So that's another trick that it can be used. Now, in a more useful sense, you would use the texture to have an actual texture on the object, and then you'd use the shading to add lighting, which is less high quality, but you can do it more dynamically because with this, it can only do what the one texture allows it to do. I mean,
That's really neat. So
can load it.
Oh, go ahead.
I can load a different texture somewhere. Like
I got a checkerboard thing.
sadly I don't actually have one. Wait, can we get one real quick? Google Images, do not disappoint me.
Or put a photograph on it. That'd be interesting.
Yeah, photograph I can do.
So 90% of the time is spent convolving the all the polygons and then doing the Z buffering and all that.
There's no, it's Z sorting, which is basically free, except that it needs memory. And you can see sort of the artifacting from that sometimes. Like,
Right.
oh, look, there's like a little bright pixel here where some part of the stuff isn't sorting correctly.
Yep.
You can sort of mitigate this by futzing with the order that the things appear in the mesh. Because what appears earlier in the mesh is always going to be behind, even if the Z-sort ends up putting it into the same bucket.
When you're doing your Z-sort, are you clipping polygons along the way?
No, there's currently no clipping except the clipping things to the screen.
Okay.
Here we go, that's with a photo. This
But
this is notably not a photo that's been sphere mapped, so it looks a bit odd.
if your polygons are sufficiently small, you're not going to notice clipping errors, right? Or lack of clipping.
Yes, you will, because as soon as anything goes behind the camera, it explodes if it's not clipped.
Oh, if it's behind the camera, yeah, but I
Because
mean,
it's dividing the view space XY by Z. So if it goes to 0,
right.
you know.
Well, I'm
And
thinking
of
that if
course, if
you
it's
have like two intersecting polygons,
Hmm.
well, would you no, your data wouldn't allow that to be in the first place, right?
you can make two intersecting polygons. It will just like sort them into the same bucket depending on. It might not even sort them into the same bucket depending on how they intersect.
Yeah. Yeah, boy,
Because
there's a
it sorts each polygon individually. Currently, it does it by finding the maximum Z and the minimum Z of the vertices, and then taking the average of that, and then using that to figure out which bucket it goes in. But you could use other algorithms, like for a floor or something. You always want it to be behind the things that are sitting on top of the floor. So you probably always want to use the deepest vertex for that one.
yeah,
So it can't possibly draw above something that's on the floor, and like you never have something go under the floor.
right.
And in fact, if the floor sorts behind something that's gone under the floor anyways, it doesn't look super wrong. You can just pretend that's not an issue.
Man, that's really amazing. There's so much development that's gone into this type of idea. The idea is that allow this to happen over so many decades.
Yeah, this is some very basic stuff actually.
Yeah, there's many levels at which you could implement those kinds of ideas.
But in a lot of ways, you can see the ideas that are something like this and apply them. As I
So
said, this like normal map texture thing, not normal map. It's like this sphere environment thing is still in use in modeling programs because you can just apply it to any model and it will look okay.
what are your prospects for cutting down on the 90% of the time requirement?
Very good, because the code that's currently in there is like proof of concept here and sucks.
So it's a lot. You said you mentioned spin 2, but probably not actually in spin 2. But you said there's a lot of inline assembly.
Yeah, I can show it. I have just found a grid texture that we can use. Give it to me. I need to save it. Put it into the right folder. Convert it to like 256 color. You know the deal.
Man, if this could ultimately be in some object where people could just define, their shapes and apply textures and then, or do it even dynamically, that would be so interesting. It would open all kinds of doors.
Yeah, a library version would be kind of neat. What would basically take up like most of the propeller with like custom memory drivers and stuff like that.
Are you using like any external memory, or is this just what's
For the current version, it's just using it to buffer the frames. So basically the finished frame goes into the PS RAM and then it reads from there when it wants to send it to the screen.
okay? So you are using some
But
external memory.
but this is very packed for even this simple demo. So it will use more PS RAM to store more data, so you have more free space to actually do something useful. Where's this color depth? Yeah, do what you can't stop. Very poor 256 color conversion, but I don't care right now.
Yeah, it's using like stipple patterns or something.
Save it as for some reason we need a gal file for this. Then it has to be put into the very normal converter program. Just some good old changing the demo while showing it off. Where's the thing? Let's get it back to screen capture. Just have to load the different texture into it, and then we can see the grid. And then I can, oh no, I actually have to run this stupid tool first. There we go. Now you can see how it deforms the grid.
Oh yeah.
Trippy.
Oh, interesting. Well, that's quite an accomplishment.
So anyways, the code for this, where do we have programming here? At this point, I have 3 screens. Like, none of them are like useful or strange. So bear with the slightly narrow one.
Hmm.
Where is this? There you go. Let's draw teapot. The
Okay.
most useful of function. So this has 2 awful functions that it calls. You can see the bucket sorting happens here. It's very simple. That's all that the Z-sort does. Maybe we'll have to make it
You're
bigger.
probably compiling this under FlexSpin, right? So it's actually not the interpreter that's doing it.
Yeah, it's not getting interpreted, it's getting compiled. But that doesn't make it any better, it still sucks. And so this is just the Z-sort. Very simple. I just eyeballed this line until it worked. For this particular scene, you have to set it up so it actually matches like the scale of your scene.
Yeah.
So that like, you know, when things are far away, they need to have multiple buckets at that range.
Hey, you could do that ZBuck, the last one where you make sure it's above 0 and less than OT buckets minus. You could just say, oh, I see. You're using modifiers, but you could do that in one statement, but you wouldn't. Let's see. Could you?
Yeah, I could, but it's more like this has a higher likelihood of actually translating into one instruction in FlexSpin.
Yeah, right.
I think anyways. Anyways, it's all getting rewritten. It sucks because this calls 2 horrible functions which are called tranVT, which does all your multiplies.
Got it.
It reads the matrix in every time with this one just because it's hard to figure out to get it loaded into registers with FlexSpin. So that's part of why this sucks. But if that wasn't the case, you'd still need an instruction here because for some reason there's like a missing space in the instruction set, like the missing link in human evolution or something. Because we have mults and we have scats, but no in between that multiplies, puts it into the next thing, but doesn't scale it down.
Nice.
That's not very nice because it means we need extra instructions. Maybe we have to illustrate the problem. I can do, if I have A and B, right? I want to multiply them and add it into C. So like C. Right, I have I have to do like morph temporary a.
No, you can use the scas instruction.
No, I can't. That's and so right, I can use
See comment.
CTMP. So that's what I'd have to do. What I have to do, I have to mouse. If I use scas, I could do A, B at C, whatever.
Right.
But that's the problem because this
It shifts it for you.
right shift by 14.
Right. It's basically scaling it.
No, we don't want that here. Because we need to do it ourselves to a different scale at the end. And more importantly, we want the higher precision results in the interim.
Right.
Because if every single multiply rounds, that's bad. It should only round once at the end.
Mm-hmm.
So there's some. I'm thinking about how this could be sped up, but this isn't very slow to begin with.
Right. It
Does the same thing somewhere down here for the there's the same thing somewhere down here for the normal vector, but it doesn't even care about the z at this point. And that's how it ends up with the texture coordinate.
you know what? One way you could speed that up is if you had all those variables that you need to multiply in a strip of hub memory, you could read them in using a set queue plus read long so that's going to take one long per clock, and then you could modify them and it wouldn't matter because the ones in memory are still unaffected. So it would save like 1 clock per multiply because.
But then you'd have to spend like 9 clocks of startup latency, like more like 11, and there's only 9 multiplies done with the matrix.
Yeah.
And also the matrix is 16-bit elements.
Okay.
So so that doesn't work. It only loads it from memory here because where else is it gonna get it? But this is suck code. Don't think this is good code. This is suck. There's also the perspective divide here, which I don't know what this number 4 here means. That's also just eyeballed. Make it work right now. And then we have the other horrible one, which is lit perspect try. So this has to sort the vertices. And it also figures out if the triangle is even on screen, which at this point it always is. Like going off the screen is fine, because this is just thinking in screen coordinates. This is after all the 3D stuff. But going very off screen is not fine. Like the screen coordinates are only 16-bit themselves. So something that's like next to the camera will very quickly blow up the coordinates. So that needs a separate clipping step that we don't have yet.
Well,
Anyways,
that's looking great.
This is calculating some triangle data. I call this realizing the triangle. And that's where you calculate all the nasty slopes and stuff. And more importantly, this funny function called gradient calc2, which also takes up like a lot of the time. This is sort of grown until it worked. Very, very garbage code this as well. So this calculates the area and also does the culling for some reason in here. Don't know why that is. And that has to calculate the gradient. So the gradients are like, how does a parameter change across the surface of the triangle? Like if I go 1 pixel down, how much brighter or darker does it get for the shade channel? Same for the UV texture channels, but it's kind of like more complicated. And of course, in reality, this at that point, it isn't just the actual UV. It's the U over Z, V over Z, that sort of thing. So it can do hyperbolic interpolation. It doesn't
Wow.
actually do that in a demo because the Z values are just hard-coded. So it's actually just wasting time on the Z, and it's also wasting time on the rasterizer. But it just is like that.
Any questions from anyone about any of this?
I could show the actual good stuff, which is down in the assembly part. Where is it? That's called span perspect. So this is actually an older thing. In the meantime, I've worked on some sort of subdivision thing, but that kind of fell through. That was too much code and like awful. So this is actually something I did earlier. So it's just, can you make this smaller? This is just this loop here. And this is what actually draws pixels. It has all your favorites. It has a QDiff. It has a mix pix. It has the RGB squeeze. It of course has the FIFO abuse.
Nice. So you're packing the pipeline for the Cordic thing.
Not entirely. It's actually like this is 56 cycles exactly because that's the time it can get from dividing something to getting it. There's actually a bunch of instructions here that you could get rid of.
Oh, I see what you're doing. Okay, I got it.
But you can't make the loop shorter than 56 unless you like do 2 pixels at once, in which case you can make a 28 loop, but then you're kind of running out of instructions to do things.
Yeah. You know very well though how to keep the pipeline full on the Cordic resolver, right? Which is used for the QDiv and
Yeah, this getQX actually doesn't correspond to the QDiv above it, which is funny. I think I figured out that's the most efficient thing, is that the getQX is actually ready just 2 cycles after the QDiv that sets off the next one for that sort of channel.
okay.
So there's the V channel, there's the U channel, there's the L channel, which is for shade. And with the U and the V, it just sort of grabs together an address. It RD fasts from that. Then it does a bunch of like housekeeping.
And it's ready
Then
to
it
do RF byte.
then it picks it up from the FIFO. And now here happens the even funnier part. When we're done with this, we can start the FIFO up again and write a word into the FIFO. And that's the rendered pixel. And it's kind of guaranteed that by the time it gets to this RD fast, that has at some point been flushed out.
So
That's important
that-
because
This,
that's important because it's this really has to be 56 cycle loop.
let me understand something though. Look at line 1293 and 1294. The QDiv starts, and then you're getting, is that getQX that follows, is that from the QDiv you just issued or from some computation, some QDiv that was issued a few before?
That's from the same QDiv, but from the previous loop. That's why on top of the loop, we do a bunch of
okay,
runs
I
to prime
understand.
it.
Okay,
or
so you're
preheat,
getting,
as this says.
all right, so you are then getting, you're not hitting every 8 clocks, you're hitting like every, no, you are, right?
This is hitting with 8 clock increments, but then it just does something else.
Okay.
So it's
All right,
getting
so
like
you're is it, well, that is kind of already as efficient. Maybe you can change the code a little bit,
it
but
gets like
you're-
3 out of 7 Cordic cycles. But
okay.
that's not really that's fine. You can see the actual Cordic operation. It doesn't take that long. It's just everything else that takes long.
Yeah. Okay.
I mean,
All
this
right,
of course
cool.
takes its 7 cycles here. Very fat instruction.
Okay.
But it's kind of needed. But because of the loop times here, we can't make it shorter than 56 cycles. without like doing strange things. I did
Mhm.
have the subdivision thing that had like a 40 cycle average over really long spans, but it had too much code that had to run beforehand. And it also caused like little wibbly wobbly glitches. So I scrapped that one.
All right.
And now it's back to this early idea. So a lot of time spent on that for very little gain, very cool. And then we have the actual raster code, which is kind of the newest. For some reason I put it at the bottom at some point. And this just figures out which spans actually need to be rendered. This sounds simple, but it really isn't.
Well, I don't think any of this is. I've always wanted to understand this stuff, but never got my head all the way around it.
Part of the problem is that you're stepping in whole pixels. The parameter gradients step in whole pixels. But the edges, they can start and end on any sort of fractional boundary. You can make it not be like that, but then you get the like PlayStation 1 effect where everything's like wobbly.
Right. Right. All right. Well, thanks for going over all that. That's really neat. So I'm really anxious to see what happens when it gets a lot faster.
So the next sort of idea is to first optimize the format for the models, because right now it's just a list of vertices and faces. So what you can actually see is that it calls TranVT 3 times for each triangle that it draws, which means it actually calls this on each index like 6 times or something. So the idea is to change the model format to sort of command stream, where we first load a bunch of vertices, like we can load a big block of them and transform all of them. And then we draw triangles, and we can alternate between these things. And that's where you can add some interesting stuff like skinning, where you can change the matrix midway through, so you can have like joints in your model. Well, that's not. Well, the joints are one thing. Skinning is another thing. Skinning is when you have a triangle that sort of belongs to 2 matrices, so it like spans the gap. Like, you know how like limbs are made of like separate shapes that sort of intersect into each other normally? That's how that's done. It's stretching the triangles across the parts. And that would be done very easily. But the problem is that this is for large meshes a bit difficult to figure out what goes in. There's a funny paper I found that is relevant to this. I love the papers. It's usually full of like weird jargon, but it's very useful what you get from that. An improved vertex caching scheme for 3D mesh rendering. Ganglin and Formis PYU. From 2006. Something about turning vertices black and white. I think I understood most of this, but I have to implement it, and that's the problem.
Yeah.
And of course, the situation here is slightly different because it's a lot more expensive to duplicate the vertices rather than just a cache miss. But I think that's the approach that I'll go with. Of course, for a small model, you can just load all the vertices all at once. They'll all fit into the buffer, which will be something like 256 vertices. Implementation on the thing so far looks like where's that even? Oh no, my windows are gone again. So far looks like this. amazing, right?
Yeah. What language is this?
This is Rust, which I figured I might try for this. I don't know, it's okay, but it has like interesting, like this is the object file. This is the wavefront object parsing thing. I basically ported this from Ruby. There may be a better way to do this. I say as I look at these like horrible copy paste lines. But look at this interesting structure. So this is evaluating a regex in this line. But then to get the captures as numbers, which, you know, they're supposed to be numbers, it has to get the capture, has to unwrap this get because it might not exist actually. So this can just error out the program if this doesn't exist. And then it has to convert it into a string because, I know, the object that comes out of this also tells you where in the original string it is probably. Then you have to pass it. But it could not be, it may not be a valid number in that string. So you actually have to give it another value to fall back on, which is unwrap or.
So why does what does that line 38 do? It's like, why are all these dots? Are
This
those
takes like a single number
semicolon?
from the regex capture and turns it into an actual number. For comparison, the line that does the same thing in Ruby looks a bit like this. This actually does it for 3 numbers at once.
Okay.
This is a single line. And also the regex is inline. So you can see where the difference in programming languages happens. This is very easy to write. And will do what you want it to do, probably, maybe. This wants you to spell everything out.
Yeah.
Which may or may not be useful, but also it runs fast and it isn't C. I don't know. I didn't want to figure out how to make this happen in C. So I just did this. Because for some reason, all the existing libraries that read object files, they don't do vertex colors. Because it's like not properly part of that standard. But all the other file formats are too complicated. For reference, an object file looks like this. Just numbers in a file.
Yeah. We should probably start moving along because there's at least one other thing I got to go over, but I don't.
Yeah, I've
This
been
is
too
like
long
super
anyways.
technical and probably it doesn't mean a whole lot to too many people. So.
Yes, it's very meaningless, even to me.
But it's fascinating stuff.
Yeah, you can do whatever other thing.
There's no end of things to learn. Well, thanks for showing us all that, Ada. That's really awesome. And man, I've always wanted to have the ability to do some kind of like 3D data presentation from live sensor stuff. So that might someday lend itself to that.
Yeah, currently I'm only working with static models, but it's gonna have animated models, and it should be able to do fully dynamic models where you can update the vertices every frame. For I'm thinking of like a clock simulation to simulate things like a waving flag, or like when a character has like a skirt. There's no good way to do this, just normal skinning. You kind of have to move the vertices more complicated.
Yeah.
But this could probably be like a data visualization thing as well.
All right.
Ada, get over your cold, and I wonder in your dreams if your cough syrup makes these programming tasks easier.
In my dreams, sometimes my dreams are like, sometimes I have dreams about programming, but they're like weird and loopy. And like when I wake up, my brain is completely scattered and it doesn't actually help. So dreaming about programming is actually not very helpful.
Yeah. Okay, let's see here.
What you got there, Skippy?
some stuff here. Let's see. Let me do a. Okay, this is not nearly as. There's not nearly the work behind this that there was behind Ada stuff, but this is useful to people who want to develop some code where you do some conditional compilation. So I added, let me pull up here the latest, this thing here. Okay, oh, there's some people on there right now. All right. Okay, is this where we are? Let's see. So last we spoke a month ago, we had got V47 working. There are a couple bugs that Uwe pointed out. Those got fixed. There was a late one today that had to do with send and receive not being right because a register location had moved by 1 and I didn't update the compiler. But of late, what I've done is I have implemented some, let's see here. Let me get this a little bigger. A preprocessor, okay, which, let's see. Oh, brother. Let's go to here. So what a preprocessor does, okay, this is it right here. It enables you to control what portions of code that the compiler will actually see at compile time. So you can get rid of stuff that you don't want and you can leave stuff that you do want. And it's a C-type preprocessor where you have these keywords, and these are now. I didn't do a thing where we opened this up so that you have to do a level V48 to make it work because of new keywords, because it would right there would be a chicken and egg problem, right? So what I did was these things are always on, but the likelihood of you running into these accidentally in your source code are vanishingly small. So going forward, all versions of the compiler will be sensitive to things like define, but pound define, pound undef. But the thing is, they have to appear first on a line with only white space in front of them. So, you know, I don't know, what are the chances of that winding up in a spin program? Pretty low, right? It could happen in a con section, but you probably wouldn't be naming variables, you know, else, end if, and these things. So it's probably never going to be a collision. So it's just in the compiler now. And so the way this works is in your source code, you can define and undefine things, and you can also do this at the command line. So the idea behind this is that a symbol is either defined or undefined. And even though it might be in the symbol table, it has a 0 or 1 attached to it that says it's defined or undefined. So if that doesn't really make any sense, but it's almost like a 0-dimensional variable. It either exists or it doesn't, but it doesn't have a value. So you can query if it exists, and you can make it exist or make it go away, but it doesn't have any value. So this is like a limited implementation of a preprocessor, but it's sufficient for controlling code that you want compiled. And the way this thing works is, if you look at this line here, the only time you can set up the master control variables is at the command line when you launch Peanut. And I could change that later. I could make a little menu where you can say, you know, here are your defines and your undefines. But this will define egg. It'll be defined. It'll make pig forever undefined. And you can have up to 16. I think I say now it's 32 max, but it's actually 16. Anyway, when you define a variable at the command line, it cannot be altered within the context of any of your source files. Any attempt to change it will have no effect at all, just be ignored. So that works for defines and undefines. Egg will forever be defined. Pig will forever be undefined. Now you can, you know, within the context of a source file, you can set up some initial defines and undefines using, these here, and that'll work for the span, the scope of that source file. But these ones that you do at the command line are going to be seen by all source files in your compilation. So, there's going to be some objects which are going to have some unique define or undefined that won't make any sense to any other object. But that'll evolve, that's going to develop over time as people use these things. So anyway, you can define and you can have defined and undefined symbols, and then within your source code, you can do these things here. You can do an if def, an if ndef, not def, or you can do an else after an if or if ndef, an else if. You can do an else if def, else if ndef, or just a straight up else in case nothing else was true, and then ndif. And anytime you do an if def or an if undef, you begin a new scope that inherits the state of your current scope, right? So if you're already active, it'll be active when you go in here. If you're already canceled, nothing in here is ever going to emit any code. And then when you do an endif, it basically just pops the state, and you go back to your prior scope of your if endif and your conditions. And I'll demonstrate how that works. Now Stephen, this is a subset of what he implemented in the TypeScript compiler. And we need to update the TypeScript compiler to contain all this new stuff like, well, what have we got up here? We had data structures. I think we are at v43 in the TypeScript compiler. So we need to add in all the data structure stuff, the debug gating, some minor syntax improvements, a couple new keywords, and then we're going to have to add the multitasking. Multitasking is, all this stuff is like super easy to implement, Stephen. The only stuff that's going to be time consuming is all the structure business. That's more complex. But the rest of this stuff is just a bunch of nickel-ante nothings. It's, it's stuff to do with the interpreter, but the compiler doesn't have any novel feature, just compiles some things. So anyway, we have a few. I have one right now. It's a predefined symbol. That's like one of these permanent things. It cannot be defined or undefined but the compiler will at runtime, or no, excuse me, at compile time, it'll have this initially set. This debug thing here is going to be set if you're compiling for debug. So let's say, for example, you have some code that you want to really only to be compiled if you're in debug mode, because it might be preparing some data that you're going to express through a debug statement, and you otherwise don't need that code running in your app. So now you can say like pound if def debug, and you can make a little block that you'll have code that will only be present if debug is active, and at other times it'll just be turned off. Now let's see, I have here, let me get this thing, oops, touchy here. I got to get this thing over so I can minimize it. So I have here a little program I put in the new zip file. It's just kind of like a little summary of this new feature. And it's this pretty simple demonstration. It shows here how you can, at the command line, you can define gum, for example, right? Or you can undefine it, which is the same thing as never defining it. But if you undefine it, like in this line, it can never be defined in any source code file. That makes like a permanent matter that gum is undefined and will be for any file within the compilation. Yeah, now see, this is 16, I think. I got to change that. But anyway, okay, so this is the entire set of preprocessor commands. So here's a little program. Everything is a comment until we get down here, right? So we can see here that we have some preprocessor command, and this is going to make just a PASM only file with like one long in it. So if gum is defined, it will compile this. If it's not, it will only compile that. They're at least within the context of this if def to the end if. So what I could do down here is I can say, let's see, let's close this. I'll say peanut, I think that thing was called preprocessor demo, but I'm not sure. And so we're going to say we want to load that thing, and we want to define gum. It's capital D, and we'll put gum here, right? So do that, and then let me drag the window over here. So now here we are, and we've got the file loaded, and this is now defined at the command line. So when I compile this, boom, all we get is that 777777 because gum was defined. Now, if I go out of here, close that, and let's say we want to do nothing or, undefined gum, so it's never going to be a thing. Now we go into here, and when I compile this, so this is not going to compile, right? It's only going to do this. So when we run this, now we get the that instead. Any questions about any of this? Okay.
Yeah, Chip, I have a question.
Yeah.
When you pound undef a symbol that's already defined, what happens?
Nothing. Like if I were to do that in this code right here, it would just get ignored.
To
So
pound undef?
yeah, if I were to do something like gum, right? Let's say it was already defined at the command line, this would have no effect. So I don't have any like compile time errors for the preprocessor.
Okay. I just wanted to say most preprocessors with the code you have written on the screen right now would always output 5555555 no matter what.
Oh, because
So
of the
undef gum
here.
would
Okay.
yeah, if it was defined, it would be undefined.
Okay, well, here's the thing. I can absolutely see what I've done. I have two classes of preprocessor symbols, right? I have the ones from the command line, which I've made permanent, because that's how Stephen explained it to me, I think. And then I have ones that are, well, I call them external and internal. The external ones that come from the command line cannot be tampered with. They are what they are. The internal ones that are basically not sharing any names of the external ones, they're completely malleable. So do I only need one class of preprocessor symbol, or do I really need two classes?
No, you really only need the one.
So you're
Okay.
saying that file content can override what comes from the command line then?
Yes. That's how C works anyway. And FlexSpin.
Okay.
Well, I can change it to that. How do you feel about that, Stephen?
If that's the way it works, I'm okay with that.
Yeah, I mean, I guess, the customer's in control of his code anyway, so it's not like you have to bar someone from changing anything, right? Because you've got all that under your control. So, okay, so what I'll do then is I'll change this so that I'm just going to have one class of symbol, and so we can introduce some at the command line for some initial values, and then we can change them within the code. And the thing about this, the way this stuff works is we can do this, right? We can go down here and we can say, we can change things. So as the preprocessor runs through your source code, you can be changing these preprocessor symbol statuses between defined and undefined. And that's normal, right, Eric?
Yeah, that's the way most of them work.
Okay. Yeah, so if you wind up in a mess, it's your own doing.
Yeah, exactly. Yeah.
As it should be. Okay, so I'll make that change. All right, well, that is actually a simplification, so that's just fine. All right, and of course you can have many many intervening levels, right? Like I could, you know, I could say, I could start a new def here. I think I had something else called B, right? And then we could say long. Oh wait, better not assume that happened. Oh yeah, actually it would be okay. I could say long, you know, whatever. So if gum is true, then it would put out the 7s, and then if B was also true in that case, then it would output this other thing. I need one of these here. So you can nest these up to 16 levels deep, which should be way more than enough. So this, you know, whenever you see an if def or if end def, it's like you're pushing the old context and inheriting the old one for your new context. And then when you do an end if, you're popping back out.
Check.
Yes.
I was going to say, check your manual. Didn't you just say 8 deep in the manual?
Oh, it is 8 deep. I'm sorry. It's 8. Yeah, because I'm using a 32-bit register and I've got a 4-bit status and I shift them left and right. So it is 8.
Okay, good.
Yeah, and the manual, it should say 8 in my other thing here. Let's see.
And then you said the number of.
Let's see. Oh yeah, up to 8 levels. Yeah, so that's correct. It's the number of command line variables. Actually, you know what? It doesn't even. I think I made it so it does 32. You can do 32 command line defs and undefs, and I don't think the way I coded it, it's fine. But it doesn't say here. I'll have to add a note about that.
Yes.
Okay. I'll have to check that out. So anyway,
Yes.
so that's. Oh, go ahead, Stephen.
So Eric, to clarify, what you're saying is symbols defined within the source file take precedence over command line definitions.
I don't know if I necessarily say take precedence. Well, yeah, I guess so. The command line is everything on the command line is defined first,
Okay.
and then
And then of course the last one in for a given file always wins.
Right.
Okay.
Right.
Now, and that would make sense for definitions, but you're saying that's also true for undefines.
Well, an undefined is just the reverse of a definition. If something's defined, it no longer is defined. So there's not a whole lot of need for a -u on the command line.
That's what I'm thinking, because how can it do anything then?
Well, in C compilers, there's a lot of predefined symbols. Like,
okay.
Like the C compiler will typically say, you know, define the symbol ARM to mean it's an ARM processor and stuff.
So you can override predefinitions with the
Yeah. Yeah.
Okay.
Yeah, see, I figured there was logic to having the -u so that you could permanently undefine a symbol in case some code within the files was trying to define it and then act on it.
Right.
It was a way to like say, no, never.
Yeah, that's not a bad idea, I guess.
But we'd have to have the permanent matter in force to make it work, to make it worth anything.
Yeah, and as I say, it's not the way existing ones work, so
all right,
it's not really necessary, I don't think.
So there's just one level of symbol. And
yeah. Now, one difference is that the each file, now this is a little tricky with spin. I don't know how we'll do it, but in a C compiler, each file starts fresh with whatever's defined on the command line.
Correct.
Yes.
Yeah, that's how this works.
Oh, okay, cool. Great.
Yeah, and you know, it would be like a real pain because the order in which compilation happens is it first drills down and then kind of comes back up and then goes laterally. It would trying to like, well, what I'm trying to say is, yeah, there's no like
in context is kind of
simple
weird.
context
Yeah.
direction for, you know, having it carry from one file to the other to the other.
Okay. Yeah, no, that sounds good. Now, the one thing, and this, I think I mentioned it on the forums, it's something that we might consider in the future. It's not urgent, but it might be kind of cool to have a pound define global that acts as though it were on the command line. But
Oh, so at that point, it gets put into the table, so all the other files will see it.
yeah,
Okay.
I did get a request for that in FlexSpin, and I ended up.
Okay, so a
doing
define, but a
What
pound,
kind of syntax would you use?
just pound define.
I don't know, pound define underscore global or def global, or I don't know. in FlexSpin, I use a pound pragma because that's how C
Right.
lets you extend the preprocessor.
I mean, the pragma isn't a bad idea.
Okay,
It's compatible.
Especially since it doesn't, since it takes the existing value. In this case, there is no value, but when it has a value associated with it, it sort of propagates it, the one that already exists, so it doesn't have to. You don't have to recreate every possible thing with that.
Yeah, yeah.
That is bad explanation, but
oh yeah, you know what? If we do this pragma thing, then that would be a way to communicate to another file kind of in an indirect way, right?
Yeah, that's why people wanted it.
Okay. Oh, here's the thing though. It has to be, how do we know though?
Without
In what
compiling
order?
the top file first, you won't find it.
Yes.
I'm sorry, what's that?
Without
our order of-
compiling the topmost file first, you won't find it.
Yes. Yeah, that's
Oh,
the
you're
problem.
compiling them in the opposite order. Yeah, I see.
Yeah.
It's last in, first out. Well, like I say, I think it's not like a huge.
Okay. I won't worry
Yeah.
about it for now.
Yeah, stop here with Peanut, and then FlexSpin can do more advanced. And
Or we can revisit it later.
Right.
Yeah.
If you figure out a good advanced, then we'll roll that into Peanut TS as well.
Sure. Yeah. In FlexSpin, I do them in order. So I just, when I see a pound pragma, I just add it to the table of things that were defined on the command line.
Gotcha. Sweet. Okay.
Okay.
Yeah. If you can point me to some documentation for that, Eric, when you get a chance.
Yeah, it's in the FlexProp documentation, in the general.md is the
Okay.
markup.
One other thing I gotta say about this. Okay, so I just came back in here and we've undefined gum, so it's gonna output the 555. So when I compile this, okay, we get the 555, but it did something extra. So when I go to, oh, it's on my other screen. So when it sees a preprocessor command, then that means that the file is going to be modified, right? So that the compiler will see. So here's what it did. I don't have the old one here, but it outputs, let's see, the name up there. See this up here? Preprocessor demo underscore pre. When a file has a preprocessor command in it, it causes another file to be output, which is the same file but underscore pre. So you can have a chance to see what the compiler actually saw. So,
Oh, yeah.
So this is what the compiler actually saw.
well, it's probably more useful to call it .pre.spin2. Just my random.
Yeah.
Yes, it's allowed to have two
Yeah,
dots.
yeah. This kind of naming is.
This is the same name format that I'm using in Peanut TS2. I just did a suffix before spin2, rather than having multiple file types appended. But
Yeah, it will create like a kind of a litter of what look like, you know, source files, but they're kind of like secondary source files. I wonder, Stephen, how do you feel about that? I mean, the .pre would allow you to erase them easy, right?
You still can. I don't have any issues with erasing on either form.
Oh, well, how would you? Because
You don't want to do a .pre without the .spin2, because then our highlighting tools don't know it's a spin2 language.
Yeah, well, Ada was saying there would be .pre.spin2, but that maybe that's unnecessary because to delete all your pre-spin2 files, you can simply say del like in DOS.
Yeah,
Star
there's no
pre.spin2.
practical purpose to that. It's just the separation between what is the file name and what is the file type.
Okay, well then I think how we have it's good then. I was having like not visualizing how to delete, but you just say del star underscore pre.spin2 and it would get rid of all those preprocessor files. If you wanted to just purge them,
Yeah,
right?
but if you have an actual file that that ends in underscore pre,
Yeah.
that's your problem.
That's a problem. Yeah, that's
Whereas approximately
probably
no one puts the extra dots in their file names by intent.
right. Yeah, I think we'll just stick with this because chances are low that someone's going to put a .pre at the end of their name without, this incident occurring and creating the file. Well, and they really the only point is if you wanted to do just a mass deletion at the command line by filtering star underscore pre.spin2.
That's why it's already a suffix of the file name.
Yeah, but I understand that having .spin2 makes other tools easier because it actually is a spin2 file. You okay with that, Ada? Or is that?
I mean, ideally, you wouldn't write them out by default at all.
Right, it's a switch. Do you write them out all the time, Chip, or do you have a switch for it?
Only all the time, but if there's no preprocessor command, it doesn't happen.
Okay.
So it only does it when there was
counters.
Generally, it's bad to litter the same directory with just derived files.
Like say that again, Ada.
I generally don't like it when the directory gets littered with like derived files.
No, I don't either.
It's kind of hard to keep track of what's the actual one.
What if we did something like instead of underscore pre.spin2, we put double underscore pre.spin2?
Well, that's a lot less likely to mess something up. So that's better. You're a lot less likely to do that on purpose.
Okay, how would you feel if I change it to that, Steve?
Yeah.
Steven? What?
Doesn't matter. I just got to follow my code too. We're making a big change for TS anyway coming up, so we got time.
Yeah. Okay, so double pre dot spin to. Okay, yeah, that's going to make it.
Yeah. What I don't like is making change for change's sake when we've already done a release, right? But Ada, are you sure it's important enough to do a .1 or .2 release?
Not necessarily.
Well, I haven't even
just sort of think it's nice.
Oh my god!
Hold on.
Yes. Somebody.
So I haven't documented this. I just explained it to you guys. That's the first. I mean, someone might notice this is happening, but I haven't written the documentation for the preprocessor yet. So
okay.
I think at this point I can change it and nobody notices a thing.
Go for it. Go for it.
Okay. Double underscore pre. All right. Yeah, I don't like littering either. I wish there was a way, I wish a long time ago I would have figured that all files that are litter would have some kind of like special naming convention so that you could always delete all of them, without any question.
You just make them go into a different folder.
Oh yeah, yeah.
Okay, Eric, I'm seeing Pragma export def. Is that the one you're talking about? Is Eric still here?
Yes, yes, that is the one I was talking
Good.
about. Yeah.
Thank you.
Speaking about, I think I can trust Eric with the rest of the pre-processor complaints.
Yeah.
I'm very wasted. I need to go.
Okay. Thank
Take
you.
care.
Ed.
Yeah,
Ada.
thanks, Ada.
And take care. Get well.
I will.
Yeah, it was in the
Okay.
basic. It was in the basic MD file, Eric, but I found it. Took me a minute.
That's funny. It should be in all of them, but if it isn't, I need to update those.
Yeah.
Do you want to implement that, Stephen, in your tools?
What?
The
Yeah,
pound,
yeah. I'll probably
pragma.
I'll pull in anything that makes sense. Of course, I'm going to
Okay.
try and keep in PNet TS. We're going to try and keep synced with preprocessor stuff as much as we can for things that make sense.
All right. Okay, good. Well, so I have a few things I need to change.
Yeah, I already took most of the things already that looked like they were useful. There's a bunch of things that we don't do in PNet that there's no point in trying to handle.
Right. Well, I think what like this basic set of things here is like 95% of what I mean. If it's what's absolutely necessary, it's probably like 99%, right?
Right.
Yeah, this is a great start, Chip. I think a lot of people will enjoy this.
I'm glad you're happy. I think so too. It's good because it's been bugging me for a long time that there was no way in our compiler to do any kind of, because I know when you get into like big projects, this kind of stuff becomes necessary and it's a big inconvenience to not have it.
Eric, a question for you, clarification. When you define a symbol with a value, are you case sensitive in that substitution?
The substitution happens exactly. Okay, sorry, which case sensitive? The value or the symbol?
The symbol itself being substituted in code when the symbol is seen. So you have a define with a name and a value.
Right.
And is the name matched in a case sensitive fashion?
For basic and spin, it's case insensitive, I believe. It should be.
Or you have different defaults based on the language?
Yes. In fact, I don't use this preprocessor for C. I use someone else's.
Okay, good. Okay. So I'm just asking because I want to make sense. I want to make sure that I'm making sense with what we're doing. And so your premise is that if the compiler treats the language as case insensitive, then the defined match also will be case insensitive.
I think that is the way it should work.
Good. Okay. I want to be consistent. And I'm not sure you call it out.
Yeah, I probably don't. And I think originally it wasn't, but I'm pretty sure I changed that. And if not, I'm certainly willing to.
Okay. So yeah, I'm trying to be, trying to be as parallel as I can to what you're doing with the compiler for things that pertain. And so I don't want to be different unless we have to be.
Okay. Well, thank you. The source for the preprocessor is fairly standalone,
cool.
or it was at one time.
Right.
It's
right.
preprocess.c.
Oh, okay.
Because Roy, I think, took it and used it in OpenSpin.
Oh, cute. Okay.
Well, I kind of helped him.
How to get a compatible preprocessor.
Yeah. Yeah.
Just use it. Cool. Okay. I was just, walking through issues I had in my head.
Yeah, no, good point. And I do need to clean up the documentation a bit. So thank you.
You're welcome. Now, where do I keep notes for things I want to do in the compiler? Here it is.
The FCC would say we got dead air.
Yeah, really.
Not
Nobody's
allowed.
talking. What in the world? Why is nobody talking?
All right, well, we got time. We can talk about anything else anyone wants to discuss.
Quick question for John Huffman.
Oh, wait, hold on. I muted him because there was some noise.
Oh,
Hopefully he can unmute himself. Hold on.
Johnny Jib, do you copy?
He's in the car, Ken, probably just going over the grapevine right now, so he may have bad connection.
Good to hear you, Johnny Mac. Well, he might be.
He came down just in time for our windstorm so we could work on one of his client projects. So I was a little late to the meeting and he was on the road to it. So he's still on the road. He's got a couple of hours, but I know he's listening because he's texted me a couple of times.
Well, just want to draw his attention to the binary downloader effort that's maturing on that thread.
Yeah, he and I talked about that today.
Okay, because
he's
a user of it, will be a user of it, and a requester of the tool.
Yeah, and I also told him that I had tested the aspect of Peanut 48 that will save a binary image for the P2 that can be loaded into the flash directly, with no modifications. You just copy it in and reboot and it runs.
Oh, good. He needs that as well. Yep.
Yeah, because in fact, while we were having lunch after we finished work, one of his P2 clients called. And so that's going to be a way for him to do that. Hey, Chip, on something I put it in the forums, but since you were asking about things, since you did that 48.1 today, but the file that the exe that you output still says V48. So could you fix that?
It does?
Yeah, because I will hang on to 3 or 4 past exes just in case. So what I did is I renamed mine in my library, the first one from the other day, V48 lowercase x 0, and then this one I just did normal, but maybe consider adding a lowercase x instead of another period, and then whatever the bug fix number is.
Well, what I did is, here's the thing. There's all these little mentions in the documentation and in little batch files where it says Peanut V48. And so I didn't want to change every single one of those so the file's called V48, but when you run it, it'll say at the top of the screen V48.1.
I know, but I keep your past episode edition. So I'll just manually do that.
Just rename them. Yeah. For most people, they just we're going to throw them away and use the latest. So
no, they're not. Most people are saving when things are this dynamic.
Yeah, well, you wouldn't want to keep the straight V48, the first one, because there's a bug in it that just got fixed.
I understand, but there's no telling that the one you released today doesn't also have bugs. I did that with Marco. Yeah. I had to go back with spin tools. For whatever reason, is having trouble downloading the latest version. So I went back a version. So, in these development phases, just, be friendly to your customers, all I'm asking.
Well, I'm trying to be, but I mean, the stuff can for my end, it seems to quickly exceed practicality if I've got to go touch up 10 different V48 references when it's like a minor fix.
But you don't have to do it in the docs, just the exe file.
And the batch files that go
Because
along
the
with
last digit is going to be a bug fix.
Yeah, the batch
It's not a
file.
feature add.
Yeah.
Okay, just, as we say down in Hollywood when it's not burning, for your consideration.
No, so
Good.
noted. Now, I appreciate the concern, but I don't know how to solve the problem. I was thinking the other day my version control is goofy, but hopefully I get the bugs fixed before most people grab the file.
Yeah, but that's not the case with some of us because you're doing a lot of stuff. All right.
Right.
Anyway, but thanks for adding that doing that feature, because that I was just speaking with my colleague Josh today. So that's a thing actually marked off my list for that product that we're going to release at the end of March. So
Okay,
we
super.
know now that we can do that, and there's two variants too. I did, this doesn't affect you, but Marco had done the same thing in his compiler. So I've tested both, and they both work.
Beautiful.
Okay, I'm glad. Yeah, so that John's talking about a feature where you can, I think, say -ci at the command line. So compile with flash image, and it will output the actual like fully baked image that goes into the flash literally without any. So it's not like the download image where a little pre-pended thing runs, does some computations, programs everything in the flash. It's the actual data that goes in the flash, which is like the loader, and then the
file, right?
And the application, yeah.
Yeah, and it's really easy because you're just doing a direct copy. I think I put my code up. If I didn't, I will. It's just a matter of figuring out how many I don't know what the term, any 4K blocks are in the file, and making sure you erase that many. And then I have a 256 byte buffer that I use for reading from the SD. And you do the same thing. You just figure out how many of those pages you have to write and do a direct copy in and reboot. And it works really smoothly. Now, I was doing really tiny files. They were just little blinky things. So on disk, they were about 6K. But, it was reloading in under 100 milliseconds.
Sweet.
Yeah.
Sweet.
Yeah, so it's a lot faster than in the P1. In the P1, we do this in laser tag. This is why this was important to me, because we have lots of devices in the field. We want to be able to just send people a file and say, stick this on your SD card. And in our applications, when the SD card is instantiated, it looks for a special file name. And if that exists, in the P1 case, of course, it overwrites to EEPROM and reboots. After deleting the file off of the SD card, and it'll do the same thing here. But we've had a problem in the past because it takes a long time to read from the SD into the EEPROM of the P1 at 80 megahertz. It takes about 30 seconds. And occasionally people say, "Oh, I didn't want to do that," and they'll turn off the power in the process and brick the thing. So I was really happy to see how fast the flash is. So I thought, because I have a circuit where he's going to use a PFET so that if you're doing an update of the memory, turning off the key switch does not power down the device. But I'm not sure I have to have that anymore because it's so fast to do the memory. But anyway, again, I know I harangued you for a few months about that. I appreciate you doing it. I need it, and John needs it, and I think other people will find it useful.
No, I'm glad, and I want to do everything you want me to do. It's just everything takes time, and I'm getting to it, and I'm looking for my little board that you get. Here it is. Okay.
Yep. Yeah, the SD.
I still need to get. Okay, so I still need to get on that. That's like the next big thing I got to do.
Yeah, because I'm using a Ray Allen version, a slightly modified by me version of FSRW that Ray Allen ported from the P1. So I haven't had any trouble so far, but features-wise, I can only have one file open at a time, and I need multiples. 2 would be fine. More would be better, but I realize that requires a buffer for each open file. So, but we do that you're doing that in the flash file system. You define how many open files you can have. So maybe it's the same kind of thing.
Yeah. Yeah, now I noticed there's a lot of discussion on the forum that people have done all kinds of work where they like, come up with numbers for like block transfer speed and all this.
Yeah, but that's for the parallel bus, and so I think
which is kind of a mysterious thing.
Yes, yes, exactly. And I
Because
think
it's
that you can't do
proprietary.
that in native spin. I think, is it Evan or Roger that is doing that? And they're using Eric's compiler so they can get, super crazy fast
Right.
speed out of it, which is necessary. Because I think, again, I can't remember, it was Evan or Roger, but they want to, do low frame rate video captures onto the the P2. See you, Stephen. But the that I don't think that's not going to be a very frequent requirement of most users. For me, it's the reason I want the multiple files is because I do a lot of audio stuff with prop builders. And I have one guy who used to use P1 stuff all the time, and he won't use it now until I can do 2 files at a time. Now, I'd rather have it on the P2 because he needs to have a background track playing and then asynchronous, foreground tracks.
Right. Yep. Okay. Hey, John, I have a question. For your all the stuff you do for this laser tag stuff, would there be any need for like some kind of P2 base? It would just take a couple of I/O pins to do like a short haul 2-way data radio.
Well, we use XB now. So one of our challenges is that we don't have any troubles with XBs in the United States. We're having lots of troubles in Europe and Africa, particularly South Africa. And surprisingly, the people at Digi have not been as helpful as I thought they would be.
Problems like the signals not getting across?
Well, the problem is, here, in the United States, we have the FCC. And so it establishes rules for all 50 states. In Europe, even though there's, some European Commission, different countries have different power level requirements, and it gets to be a little nutty. We have to preset power levels in the XBs when we send them overseas. But the problem is our tagger menu allows you to change that. So we have to tell the customer, don't change this or you could get into trouble. So it becomes problem. So we're looking for another solution. While I was down in Florida at that convention where we showed the tower, I spoke with Motorola and I spoke with a couple other companies, and right now we're struggling. Nobody has much of an idea. So one of the things that I just bought a couple of bits, and I'm going to look at it when I have a bit of time, is LoRa stuff, because that seems to be very popular and being used everywhere. But what are you thinking?
What is your distance?
It could be up to a mile.
Okay.
Yeah, that would require some transmit power, I think, huh, Stephen?
Yeah. Yes.
Yeah, because I was here.
Useful antennas and things like that. Yeah.
Yeah. Because on the XB we can run an external antenna if we need.
You know what frequency the XB runs at?
It's 2.4 gigahertz in that, because it kind of overlaps with Wi-Fi stuff.
Okay. And what about LoRa?
I don't know much about it, except a lot of people are excited about that it runs everywhere and at long distance. So
it looks like
just a minute, I'm looking.
I am, yeah, it's 860 in Europe. It's 860 to 870 megahertz.
Yeah.
North America, it's 902 to 928 megahertz.
It's also similar to XB. XB covers 3 of those ranges too.
Yeah.
XB is 902 to 928, 865, 868, and 2.4 gigahertz.
And we're all kind of spoiled by XB because it's been around forever. I mean, criminy, there was basic stamp XB stuff a long time ago that what's the gentleman's name who did so much good work on that? Is Ken still on? I guess he's not. He would anyway, there was a college professors that did that. And it's really nice because it's a very simple serial interface, and it works nicely.
Sure. Sure.
You know, I've used it in all of our stuff, and for like Johnny Jib, uses it in a couple of cases. We've done, and then we've done some of the nice thing is they have some high powered different radios in the XB range that are like 900 megahertz or in that range. So John and I a long time ago made a baseball field camera controller where one guy could operate 4 cameras simultaneously, and we were sending the messages through these high power XBs. So it would be nice if there was something that competed with that was as friendly to use. You know, there are lots of solutions out there, but none of them seem nearly as friendly as the, you know, very simple 2-wire serial interface of the XB.
Yeah. And does the XB for that serial interface, is it just like a, you know, does it have like forward error correction, or is there any?
Yeah, because your packet you're sending into the XB, and then underneath it's using 802.15.4. So the communications under the hood you don't even see, and it's doing all of that. It's doing collision detections and retries and all of those kind of things.
Okay.
So when your message comes out on the other side, you're in really good shape.
You know it was for real.
Yeah, exactly. And you can even do things. So, for example, we have a process where the master computer of the game will ping all of the taggers. Well, it just sends out a message to the tagger that the tagger ignores, but you can set a bit in the XB message that says, "Tell me that message got there," and then without any intervention from my code, the XB radio in the tagger sends back the ping acknowledge to the radio. So that way we can scan and see who's alive and who's not. And, you know, so there's lots of little niceties like that. Most of the time we are processing the messages, but there's a time we just want to say, you know, hey, who's there? Are they alive? You know, is the device alive? Because, you know, if it shuts down, obviously you won't get that response back. And then again, it's a no code thing from my point of view. It's purely on the other end.
Okay. Well, I've been doing some just playing around here, and I can really nicely handle IF frequency of like 1 megahertz, and I've been able to like decode 16 QAM pretty well. And the propeller can output directly pretty well, like, you know, 80 some odd megahertz. And I need to do more experimentation. And I can send that directly off of an IO pin, and with you know, phase and amplitude modulation. And then to get the signal back in, I've been making little mixers, so I can have one like a smart pin just output a square wave for an LO local oscillator, and then mix down stuff that's up high down to the 1 megahertz IF range, and then I can fully inspect it, you know, decode it, do all kinds of stuff with it. But what I don't have is like good circuits, which are only maybe several components, but it's like the recipe is significant. Maybe the arrangement of parts is significant. You know, to get those the signal to go out further, and then to have a good sensitive receiver on the receive side, because those are things that, you know, the P2 can't do directly,
right?
Because they involve signals that are like, you know, 100 dB down, right? So it's very delicate, but so that stuff has to be in some kind of circuit that involves, you know, resistors, caps, inductors, and transistors. But anyway, if so, there's, you know, all kinds of stuff about how to do that business that I don't know about. Stephen knows more about. And then there's all the regulatory side of it. But
yeah, that's the real hassle, is the regulatory side.
That's why you get the FCC certified devices. Yeah.
Exactly. Yeah. You know, a little tiny company like ours, you know, when I worked for Flotronics or even at Toro, we were routinely getting stuff certified. because it's big companies, you could afford it. But a little tiny company like ours, we have to use pre-certified parts.
Right. So we can't just like build it and then put Stephen Morocco's call letters on it.
Nope.
Well,
Stephen will get in trouble.
well, given the Europeans are threatening to arrest Americans for their tweets, you know, maybe we shouldn't take a chance with you know, breaking their radio laws.
Right.
It's fraught with all sorts of trouble. We got in trouble working on with Homeland Security, working on satellite technology between the amateur radio satellite groups between Germany and the UK and the US. They shut us down.
Just because of spectral pollution or something?
Negative. Satellites are control technology.
Oh.
So they said, we understand your hobby. We understand you guys do radio communication, but no. Basically, no. And it's going to cost you a lot if you persist. So all of us just quit.
That's too bad.
We need money like Elon has, then we can do it.
Yeah, really.
Yeah,
No kidding.
he can have any hobby he wants. Although his is currently catching skyscraper-sized buildings out of midair.
Really, with chopsticks, yes.
Yeah.
Too much fun.
Yeah, I always think, you know, one of the things, you know, being, you know, a nerd, you know, I'll watch YouTube videos and I see people will go interview Elon a lot. You know, there's a couple of these space-oriented channels, and I will always send those people a note, say, hey, that rocket didn't just fly by itself. There's a whole bunch of computer horsepower and programming running that. Why don't you go interview the programming team?
Right.
And let's talk about that, because I was really surprised that the main loop of the code runs at 20 hertz. This is on their Falcon rockets, the ones they launch every other hour, it seems.
Yeah.
I see them flying overhead all the time. I go stand outside and watch it go over. But so their main loop there runs at 20 hertz, and then their critical sensor loop runs at 50 hertz. That doesn't seem terribly fast.
No, well, think of the inertia of
Doesn't
something
need
that
to be.
weighs
Yeah.
millions of pounds.
Yeah, exactly. Because even the Falcon rocket, it looks small on TV, but I went over.
Propeller is not.
You know, Erco on the forums. He lives over on that side of Los Angeles, and last year, I guess it was after they released us from COVID prison and we could travel freely. He said, hey, Johnny Mac, come on over. There's a tech fair. We can go to that and we can have lunch. And yeah, so we did all that. And then I went to SpaceX, and even that small rocket, you can almost, you know, a man our height can walk underneath it. You know, your head would hit the engine bells, but that's still pretty tall. It's somewhere on the order of 20 stories tall as just the main body. It's not with the payload. So so to your point, there's a lot of inertia there. And even though it's flying at the speed of sound, those changes aren't. I mean, but I watch every launch I can. I watch because I'm just fascinated, especially at the movement of the grid fins and all that. Because it's like it's a skyscraper-sized lawn dart that lands on a platform in the middle of the ocean, which is I find fascinating.
Absolutely. John, which LoRa modules are you playing with by chance?
I don't know. I bought them off of Amazon, so
I'm looking at a bunch of them. They're all.
I just grabbed a generic one with a case, so I didn't even look at it very closely.
Okay.
Do they have the callback, retry, and all that business built in, or do they give you just a module when you implement the protocol?
I don't know. I just, you know, I did when I was working for that IT company for a bit, we started experimenting a little bit because we were, you know, our red teams were attacking sites around Los Angeles, and we were looking for ways to have more data communications that we could, you know, where we weren't using standard equipment. We were trying to specialize it. So we started experimenting and had some interesting success, but that was a long time ago. So I'm kind of going back looking at that. Just, like I said, just trying to find something that we can use in Europe, because we do have customers there, but our gameplay really our competitive thing is that we're not using Wi-Fi. A lot of the internal people do use Wi-Fi. But then you end up, and one of our customers was, or a competitor's customer is telling us they tried to set up a game on a university campus, and the blue team running IT on the university campus saw all these weird signals on their Wi-Fi and blew up their game. So, so all these people that paid to play laser tag on this university campus got shut down because the blue team in the IT on the campus said, hey, we don't recognize any of those signals, and this could be an attack.
So they didn't really jam the signal. They just said, get out of here.
Yeah, well, they knocked them off their wireless network.
Oh, because they were using Wi-Fi.
Yes. Yeah, where we don't. We're using, the nice thing about the XB is that it's point-to-point or point-to-multipoint really easily. In fact, we don't do it anymore, although we're probably going to go back to it. But there was a case where because our optics, even though they're inexpensive, they work really well. So under good conditions, you can shoot somebody 1,000 feet away, and you might not see the little sensor light up on their gun or on their headband. So in the old days, we had a thing where, let's say, Chip, you and I are on opposing teams, and you shoot me. The bullet that we send, I'm doing air quotes around bullet, is an IR packet. And within that IR packet is your player ID and your team ID. And that's what we use. If you look at the way the XB is set up, there's two addresses that you can use to talk to an XB. There's a 64-bit MAC address that is inside the XB. So you can send a message that goes to a specific device using its MAC address, or it has a 16-bit address they call my address. And so it's 2 bytes, which works out perfectly because we use the team ID as 1 byte and the player ID as another byte. And we can put that into the MAC. So what that means is if you shoot me, I know it's you who shot me, and I can send you a message back that says, there's a little audio. One of the recordings says, good hit. So you know that you hit somebody, but, even if you didn't see it happen. So that's the neat thing. Now, the previous owner of the laser tag is a little bit of a lunatic, and he decided, he wanted to do a demonstration where he set up 10 taggers on a table, and then he shot them with another tagger in full automatic mode at 800 rounds a minute. And we weren't getting all the hits, but I said, we don't have a big enough receive buffer for all of those messages. And so that's why he disabled that feature. Now,
there's some collision occurring too, probably.
Well, but you can program around that in the XB. That's the nice thing. The XB handles that really nicely. So you can set up parameters in the XB that will help you with the collision stuff and take care of it. Our problem became that, the shot message is about 25 bytes, but if I'm getting 100 of them in, I just don't have enough space on the P1 to handle that. So we disabled that feature, but the reality is nobody's going to be able to back up 10 of their, the other team into a corner and shoot them at the same time. It was just not a realistic thing to have happen. And so we lost a feature. But that guy's now no longer in laser tag, so we can go back to doing the right things. But again, it's nice with the XB. It's a very simple thing to talk to one. Now, what happens in the laser tag is if, let's say, you shoot me and you kill me, then in the old days, you would get a direct kill message. Now it's an indirect kill message because the tagger sends a broadcast message so that everybody in the system, including the scoring system, can hear. And it basically says, I'm John, Chip just killed me. And so your tagger, since you're Chip, your tagger would say, oh, that's me. And then it would say, good kill. So you'd still get the kill message, but it's a little bit indirect. But then all of the other taggers, because one of the, we do a lot of kiddie games, so we have mom and pops, that will have 20 or 30 taggers, and they'll go out to a park and kids will play laser tag. Well, because of this scoring situation is all built in, at the end of the game, you can scroll through the little menu and you can see which team got the most hits. You can see how many kills you got. That it's all built in. You don't have to have a computer to work with it. So this is why, we're very popular with small scale things. And again, a lot of this stuff is kind of built around the flexibility of the XP.
Right. Interesting. Do you know when the XP sends out one of these messages, how many bytes are in it? It's like 16 bytes of data, and then how many, like, does it take less than a millisecond to send the whole message?
It's very fast, but I don't know what's happening underneath, because you're pushing in a packet. So let's say it's 15 bytes long. You're gonna get a packet out the other side that's not the exact packet, because I'm not using transparent mode. Because on the other side we will get so on the front side we're saying, hey, send a message. I'm saying send a message to Chip. On your side, you get a message and it says, oh, this is from John. And you'll also get like the RISI measurement is there. We're going to start using that. There's a game feature people want where if you get close to a device, you blow up. So we're going to be using we're going to make it a very simple prop that just emits a message every, periodically. And then if somebody's very close to it, their RISI value will be very high, and then it'll kill them. And so the message going out in the way that we're using what's called API mode. The message going out to a tagger, and then what the tagger receives on its downstream side they're not one for one in bytes. So that would be, you can do that. That's called transparent mode. But then that's usually just a one-to-one connection. And it's kind of like, like you had wires, but you don't have wires. And in that case, what you have to do is preset the XP so that in your XP, your receiver would be John, and in my XP, my receiver would be Chip. So we're only these devices are only talking to each other. And in transparent mode, then you just send a serial stream inside of one and you get the same serial stream outside of the other. But, in transparent mode, you're not able to do point to multi-point, which is obviously a big feature of our game.
Yeah. All that stuff is just a matter of software, except the only place you need the hardware is to generate the carrier wave, which can be modulated a number of ways, and then to selectively, tune a carrier wave, and then so that you can get it into some kind of intermediate frequency of, maybe 10 millivolts, and then you can decode it. So all these schemes are,
it's that RF stuff though that gets, that's where the government gets involved, and,
right.
Things become a little crazy.
Yeah. Yeah, but the ability though to decode a small signal, that's doable on the P2. We have that super sensitive ADC mode where it's like 30 millivolts, a span of 30 millivolts. So you have to capacitively couple to the pin. But then, depending on how long you look at a signal, if you're using the Gortzel circuit, you can get down to just a few microvolts and receive, discernible messaging. But
it's a slight change of topic, but in the same realm, because it's all RF stuff. I'm not much of a musician, but I play guitar a little bit and other things. And I on social media recently, I came across this lady in Europe who's a professional theremin player, and I thought, man, the P2 would make a kick-ass theremin because you could have the frequency and volume stuff would be Gortzel pins, right? And then it just allow you to, in that case, because I think this was made by Moog, the thing she was using, And so, you know, you can change you know, usually you would have a sine so you get that nice pure sound. But if you change a sawtooth, so after we get through this SD card stuff and a couple of other things, I'm gonna push on you about musical things, because I know how much you like music. You play piano.
Yeah.
Our friend Ryan Clark, who, you know, works for a scary 3-letter agency now, he's a musician. He has and we've talked about it, because there seems to be a kind of, well, if you think, you know, look, Ada loves these, you know, 90s style game console things. You know, I have no interest in that, but she clearly loves it and does all kinds of neat stuff with it. There are lots of people that are getting back into old school modular analog synthesizers, it seems. And so, you know, Ryan is very busy and I'm very busy. We thought, man, the P2 would make a really neat rack mount synthesizer module for that crowd.
Oh yeah, we have enough resolution that you would never hear any granularity in any signal.
Yeah. Well,
I mean, we have it in terms of time, through speed, and through resolution.
Yeah. Yeah, because I saw of this little processor that's called and it's a processor module. It's not a custom piece of silicon. It's called a Daisy Pod. And I think it uses an STM processor and then a big chunk of RAM. It's got a big giant RAM chip on it. And then it's got external 24-bit ADCs and then some reasonable DACs. But the whole thing, they just wrote a whole bunch of libraries. So you can program it very much like a Schmarshmino, and you can do audio projects. So people are making custom effects pedals out of it.
Oh, cool. Like flange and choral.
And I thought, man, the P2 could probably do that, you know. Maybe it does need some external memory, but you've done that. But because I have one, I mean, it's sitting over by my guitar. One of those, remember that there was a guy who made a thing called the Coyote Stomp Box with the P1. He made it kind of a customizable stomp box for guitars, you know, and that was ages ago. And you certainly didn't have the horsepower and then the direct analog output capability of the P2.
Is this the Electrosmith Daisy Pod?
Yes.
Chip link coming in.
Yeah, and it's pretty inexpensive and you know, and I've seen lots of custom pedal projects on YouTube that people use that. And then, you know, they're being very cool. They're open sourcing their code. And so because the Daisy Pod library has all the kinds of normal things that you would want to do to build an effects pedal.
Interesting.
But I was thinking there's probably enough resources in the P2 to do that without a lot of outside stuff, if anything.
Just your R's and C's for good sound and audio jacks and buttons.
Yeah,
we made audio board is kind of already that, your multi-channel audio board.
Yeah, it has like 24-bit ADCs, and we found that just ganging up 4 pins in parallel in 75 ohm mode is like a direct output to headphones.
Jeez.
No amplifier needed.
Jeez.
Wow.
And it sounds good. You oversample it and it sounds good.
Sounds like that a P2 pod with an edge on a motherboard would be a simple thing to do.
Well, I haven't built it yet. I bought a kit a while back that's a little monotonic synthesizer that has it's not even an STM. It's one of whatever the processor that used to be on the original Arduino. And it doesn't sound half bad, or at least the recordings I've heard. And I thought, man, that would be an excellent kind of P2 project for experimenters. And it uses a little, you know, like a capacitive touch keyboard kind of thing. So, you know, it's all on one PCB. And I thought, man, especially since the P2 has the ability to do direct encoder inputs on the smart pen. So you can put encoders with buttons on there and, you know, set up all the parameters. So again, that to me, I think that would be a neat kind of, you know, hackable hobby product that would help get the P2 out into, you know, an audience that might not normally think about it. Especially since it has all of these capabilities that, you know, have to be, you know, where you need enhanced circuitry for standard processors. And, you know, that stuff just comes right along with the P2.
Mm-hmm.
Well, this time I have to go. John.
Yeah, I do too.
Okay, Stephen, thanks.
All right. All right, good.
Good night, everyone.
Take care, everybody.
All right. Anyone else want to talk about anything?
I am still driving back from LA.
Oh yeah, John said you were. I think you had disappeared for a little bit.
Yeah, I keep getting phone calls, so I drop off and then come back. But it's been very enlightening.
Yeah, I like these discussions. We cover a lot of stuff.
Okay, can you hear me?
Yes.
Yeah, I missed it. I've got a sinus problem, and the medication made me really sleepy, so I missed most everything. So it said it was still being recorded, but I'll have to catch up, I guess, on YouTube.
Oh yeah. Now, let's see. We've been going for 3 hours now. I could stop the recording. Should I do that? Or do you want?
Maybe if we're
Okay.
off topic. I was trying to get in before John left when you were on that topic of the theremin.
Oh right.
It seems like I read posts on the forum about somebody that was active on the forum that actually was involved in that with a class, a school class or something, using the P1, but I couldn't pull it up. So I don't know how old it was, but it runs in my mind that somebody was using the P1 to do what he was talking about, synthesizer like that theremin.
Yeah, well, I guess it's possible. You know, I kind of remember something about that, but man, the P2 would be way better at it because it just has so much more sensitivity, resolution, and speed.
Absolutely. Absolutely.
Yeah, there's so many things I'd like to kind of experiment with. The other night I started playing with this radio stuff just because I've always thought, you know, this ought to be possible. So I started just looking around, and AI is really great for getting you in the ballpark right away. Like, you know, asking about basic modulation schemes and whatnot. So I started implementing this 16 QAM, and I had it all running and everything. And then I realized later that when you're mixing, you know, when you're doing more than phase sensing, when you're looking at analog, you've got to do a lot more. It's not really much computation, but it's a little more. And so I switched the effort over to just binary phase shift keyed. I think it's called BPSK. That's what Bluetooth uses, where you're just outputting a constant carrier and you're flipping the phase by 180 degrees every so often. And your receiver can do as little as just check relative phase from one symbol to the other, like wait for a phase transition, and then you could just pretty much be serial after that. So I've moved it that way. But the QAM stuff was really neat because you could actually see the little point constellation that was resolved from the phase and the amplitude of the incoming signal. I want to kind of set that up just to show maybe next month here, because it was pretty neat. And there is a like a mixed signal oscilloscope mode in the P2 where you can grab some scope DAC. The DAC can feed this thing called a scope smart pin, and it'll output like an 8-bit sample every single clock. So you can see signals in decent form up to like 4 megahertz. And then you start running into the bandwidth limitations of the A to D converter. But I can show like the whole 1 megahertz intermediate frequency, you know, drawn out. And there's a way the streamer can capture a set of I/O pins and a set of scope pins all at once. So it's like a multi-signal oscilloscope. So I wanted like, I think I'm going to have to make a new debug window that is an MSO, so you can see time-aligned analog and digital. Although the analog actually is a running summation, a weighted summation of the incoming signal. So it's not, I guess, let's see, if we've got there's going to be a little bit of delay there, but it doesn't matter as long as it can correlate with some digital phenomena. Then I can, because to work out a receiver, you really have to be able to show, you want to see the IF carrier, what it actually looks like, and then you want to see a bunch of little, you know, binary like logic signals saying what is the demodulator perceiving, and that's how you develop something like that. You can't just do it, you know, without those things, because you have to be able to see what your software is seeing in something like real time. So I've been outputting analog and digital signals to my scope, which is like a dual channel with logic analyzer. But I'm thinking we can do all that on the P2 and just have a debug window. And then anybody that grabs the file can see the same thing I see, which is the actual phenomena, without needing any fancy scope and a bunch of wire harnesses and all that. All they'd have to do is tie some I/O pins together so that they can take the analog points, bring them into some I/O pins that are configured as scope inputs, and then that data gets collected. And then after you gather a bunch in, and then when you have a trigger condition, then you just output it to the debug window, and then you see like a nice parallel update of all your signals and your, you know, both analog and digital.
I would definitely like to see that, try that on.
Yeah, there's so many things that can be explored, you know, and I've also wondered, like, with the time of flight, because we can resolve with the Gortzel circuit, you have, you know, let's say we're running at 320 megahertz, pretty fast, right? So that's like a 3 nanosecond resolution on time. But you can resolve many, many bits of subsample time by the slight shift of the sine wave going into the Gortzel thing. It'll because we have a 32-bit angle that we're accumulating, you know, so we can have, I almost wonder, like, if it could do some kind of like time of flight stuff, or would there be some other issue that would make it not work? But like for LED, you know, for like a laser, where you pulse it and then measure the time back, or the if you're continually AMing the laser, you should be able to resolve some really good angle stuff that should be proportional to distance or flight time. But I don't know if that will work or not, but it seems to me it might. But it might be that there's some kind of noise in the A to D that gives you enough indeterminacy that maybe you can't do it, but maybe it could be done. But I'd like to experiment with all that stuff to see.
Yeah, maybe it could be done, but like I say, the signal, you may have to do a lot of filtering or something else, massaging the signal in order to make it
right
where you're still not crashing.
Mm-hmm. Yeah, there's all sorts of fun stuff.
You guys, fuck.
He must be in traffic.
That sounds like sounds like it.
Anything else anyone wants to talk about? Well, I'll end the meeting then, and look forward to seeing you guys in a month.
It sounds good to me.
Thanks everybody for being here today.
See you, Chip. Good to hear you guys today.
All right, thanks for coming.
All right,
See
bye.
you all later. Bye-bye.